I talked with Daryl about how some tools in our industry have damaged us. For example, the test automatization tools charge us for licenses, for the amount of executions we do, the amount of testing cases we do at the UI level. Anyone working at automatization knows the Conf pyramid and knows that I'm doing an anti-pattern with this. So the tools vendors have incentivized a bad practice that has made a lot of companies to try to incorporate automatization and fail and say automatization doesn't work. Now that you mentioned bad experiences and bad practices, or old practices, we're supposed to be in a transition to continuous testing. We have a lot of practices from organizations or companies that don't want to do long cycles. We want to do sprints, and I can see in each iteration how everything's going. This is not the correct approach. But they feel that what they're doing doesn't work, and that's a bad problem. Eric was telling us that the good practices, a good practice is something that has worked for me in the past, or that I saw and I liked. Adequate practices, and it's always going to depend on your context, of course, and there you'll see your skill to see what worked in a context and take it to another context. It's also about understanding the value and the investment of testing. Sometimes when we think of client proposals for a whole team of developers in a sprint, they add testing. It's in us to understand that it doesn't have value. It's going to be late. You're not going to be able to hand it in time. We have to change the mindset. The value of testing is to add it from the beginning. That's the old mindset. To put the face of testing at the end. And we have to do everything together. I remember I had a conversation with someone that said the development team and in performance as well. What you identified at the end is wasted money because you're going to have to begin again. And not even in the waterfall development did that work. Leaving the testing for the end. Start thinking about testing for the end. And if they respect those 2 months, because development starts taking up time, and maybe you have little time left at the end. Julia, question. Thinking about your role in a commercial area of a company dedicated to offer quality services, what reasons or complications or misconceptions or trying out a bank system. I have another background, and in the case of a video game, the business background will be your knowledge in gaming. We're trying a game. So the end user is going to be a gamer, so you have to know. If I can add something here, some experience in this topic. It's also a mentality that if you don't have that previous experience, that mentality of jumping, of trying tricks, for example, in gaming, so that those kinds of details go into game testing. If you don't know those common things that happen in gaming, you're not going to know what to test. You can do exploratory testing, but there's very specific things that happens with gaming that if you don't know the dynamics of what you can do with cycles or storylines, video games have a lot of those. So I just wanted to add that. I don't know if you had anything else to add. Also, I want to ask you, what are the challenges that are specific for performance testing? Well, those of you who know me know a big one. All organizations confuse performance with just overloading the system. Maybe that 15 years ago was the standard, but now we're on the cloud, we're with microservices, we're with agile, and so we need to care about performance because everything goes continuously is advancing. Theoretically, we know. We need to know how it works. Not just trying everything that's coming, the new releases, we have to make sure that they are quality. If we have a situation like a Black Friday or promotions, or that's a big one, but not for everything we have to do this. That's a mistake or a misunderstanding that comes from the performance history. A lot of companies think of performance as just hitting the system until you kill it. This is not optimal. And with the cloud, with distributed systems and microservices everywhere, sometimes the challenges, you can't really beat a system to death because they're elastic and we're going to have a lot of data. Tomorrow comes another sprint, another release. So that makes me see that they've been experimenting it. We don't freeze the environment. If there's a strong season coming and we don't have to do releases, we have to have this working. The strong season passes and we keep doing the day-to-day. There's been a lot of changes in performance and a lot of companies want to do it like this. Isn't this what we're talking about, of showing the value of including testing at the proper time? We've been participating in conversations where they've told us, I love what you do. When do I call you? When do we start? Now, yesterday. It still exists, that idea. We've been insisting as an industry that please don't leave us for the end. Invite us in at the beginning. We need to show why. Why is this necessary? Why will we make a difference? Why is this the way? Why can we change things? For performance, general projects, in gaming, it's important. So I wonder, what are the mechanisms that we can use as support? Eric has been talked about the difficulty of communication, how challenging it is to be able to communicate as a manager effectively to the rest of the people, to our peers, to our bosses, to our employees. In the WOPR, we talked about documentation a little bit. So I wonder, is it through reports that we need to show our value? What do you think? It has several sides, this job. Even thinking about it as a general, in a general sense. I've been working in this for 20 years. And 20 years ago, if we did testing, anyone could do testing. Now it's a very professionalized role. We need to invest a lot of time. Companies need to invest in training, and that's going to make a change. We need to know about everything. We need to be trained in development, in quality. It's very holistic, and we need to empower ourselves with that power, and we'll keep changing then. We're on the right path, but we need to keep going. These conferences help a lot because we can share what we do. We don't just participate in a micro process, we're part of a bigger thing. So I love the training part because I remember years ago I interviewed someone that had 10 years of experience, and when you started asking them, they had like 1 year of experience repeated 10 times. If we are not training and growing all the time, we are not going to give value, and we're going to give other people the idea that testing is done by someone who's not trained and doesn't want to learn. So we are responsible to keep growing personally and show that our discipline is something that adds value. Communicating the benefit of testing or intra-team communication. This applies for a lot of things. We need to take into consideration the audience and the channel, because Eric talked about management, caring only about monetary impact and how that impacts projections. We've had, in some circles, we've had talks about scripting and commands, and they're not interested on the human side. They're interested just on the money or effectiveness or code or tricks. And the medium, the channel to communicate, if we have developers or scripters, sometimes a GitHub README document is more than enough. Management's going to want a PowerPoint. Some people are visual and need a video. Some people want documentation. So this has to be taken into account. The channel, it sounds like rocket science, but everyone is going to have something that works for them. And ask, not just assume that we know how people want to receive information. This is key, what you're saying. The team you are inserted in daily won't receive the same information, or won't need to receive the same information as a manager that wants to look at the macro situation. It's not the same information for everyone. Sometimes the information we give them is not the information they want. We have to give information of value, and it has to be a back and forth because we build everything in a team. Totally. I was going to say that in formats, I love during the weekend, we went to Punta del Este with most of the speakers, and we could show our country to them. And Mark, who's around there somewhere, he had to prepare a report for his team. And so he filmed several of us asking a question. I asked a question of Wycliffe is a part of a team, and I had no idea what the answer was. And he answered them in the beach. And remember that in the States is the winter, so he generated some jealousy, and it ended up being a video that got projected. And it was very entertaining to see and effective because he could answer the questions that he wanted to show. inform. So the ways, change the experience, the ways in which you do things. If we just send a GitHub page or a TXT, maybe most people will find it useful, but a lot of people will find it boring as well, not interesting. It's just 2 pages of text and it's not attractive. Maybe they just read the first 2 lines and they won't read the other information. It's very variable. It changes. So the channel is very important. We're talking about reporting and visibility of different layers and levels. We assume when we work with a team that the communication flows, and we assume that the information goes up, and we don't validate. It happens as suppliers as well. We work as suppliers for a team, and we assume that everything is going to be great and the rest of the organization is going to see all information. But it's important to be proactive and make sure that the information gets to where it needs to be. A lot of the times, the information of the value is not shown. I'm going to give you a small analogy or perspective of CI/CD. You throw information to the audience. We have to have a philosophy of always observe to see if everything's working, what they're using, what they're not. In theory, what we should do is to do 10 modules of a project. We're focused on the user. We don't have to be focused on something that the user is not using. So we need to close the circle and to ask if, hey, is this working for you? Are you assimilating? We just need, I like to do long stories and they just need 3 bullet points. We have 2 minutes, so I'd like to close with a small advice. What would you give as advice for someone who's in a testing position, being as a tester or a manager, to be able to show the value of what they're doing? Be curious and try to be involved in every group. Get information from all teams and get nurtured, and you're going to do a much better job. Presentate, iterate, and validate, and have continuous feedback of communication of what we're showing, and close the circle like Leandro said, and build in the long run. Don't get close, don't be focused on just one tool or just method of communication and just one audience when you're talking about quality issues and technology topics. Thank you for participating, for your knowledge, your perspective. This is something that's very challenging, and we all need to improve the way in which we communicate and we show our value, because this is going to help our community to keep growing, and our discipline to keep getting more professional. Thank you. I hope to learn more about the issue. I came into the technology world and I loved it. It's a very good experience and I find it fascinating. We want more women to get into this industry and have more opportunities. The Convertite is a doorway to the world. I came into the technology world and I loved it. It's a very good experience and I found it fascinating.
Who I am. My name is Henrik Rexed. I'm a cloud-native advocate at Dynatrace, and I'm pretty much focused on the topics I just mentioned, so Kubernetes, OpenTelemetry, OpenObservability in general. Prior to that, I spent my whole career on performance engineering, so I love performance. That's why performance is still in my heart, even if I'm touching more observability topics. And that's why I'm one of the producers with Mark and Alejandro on PerfBytes. And 1 year ago, and a half, I would say, less than a half, I started a YouTube channel called Is It Observable? So I'll make a teaser at the end, of course. You'll have to watch it, you have to subscribe, you have to give me some feedback so I can improve the content. So check it out, it's out there, it's made for helping people to get started, so it's free material, so yes, feel free to use it. So what are we going to talk about in the next 28 minutes, exactly? So first, we're going to do a gentle reminder on the OpenTelemetry project in general. So there are various components involved in the project, so we're going to touch base on this. We'll see that if you want to start instrumenting, we're not going to do any code for sure. I'm just going to remind few objects that are meaningful that you understand those. So then once you have going to touch base on those, you will understand what those objects means for you. Then, of course, we'll see that we are giving the hands of observability back to the users, the developers, so it means that the potential we're going to produce metrics logs from our code directly, and we will see that we need at least to check a few concepts about quality of the observability in general. And of course, we'll see how we can improve ourselves, what's the best way of getting started. All right, are you ready? All right. All right, so once upon a time, I don't know, we're going to go back in the past, a couple of years back, and at that time, people were calling it mainly monitoring. I'm pretty sure that you're familiar with that term. And at that time, there was a couple of vendors that were providing solutions that helping you to observe and understand what's going on actually in your environment. Obviously, to do that, as a reminder, we will deploy agents. And those agents were basically getting on the host's level, CPU, memory, disk, whatever. And also, we were able to produce traces out of the application. So that was wonderful at that time. We were pretty much in a control environment. So a physical server sitting in a closed environment. So basically, we're controlling the environment so we can deploy those agents without having the need to deploy or remove them and redeploy again. So at the end, with this quality of data, we were able to report lots of meaningful information. We were super happy. And one of the features that was there is about instrumenting and profiling our code. And the market was a bit inconsistent. There were vendors like Dynatrace that were doing everything automatically. So you were just shipping the agents, and boom, by magic, everything was instrumented. And there was other solution where, well, you had to precise what you want to see. But as in general, if you were enabling profiling, I don't know if you've been doing testing with profiling enable, you had that situation where you try to use the application, but it's barely unusable because the profiling is like stuck in the thread, and then you're stuck and you're not unable to use it. Well, this is over. You will see there's great news. We can do profiling now. Then all the things that change is that the fact that our IT environment has changed. Instead of being in an on-premise environment, very closed environment, we moved our workload to the cloud, and those workloads are ephemeral. So you can spin in a pod or in a node, and this node will disappear in a few minutes, potentially. So the challenge of monitoring has obviously changed. And the other also aspect is that methodology in general has changed. We are not doing waterfall or whatever. We're doing more modern approach, and we need observability to improve. So we need something to help us. So the market is in danger. We need to find the right solution. And the solution for this was moving from monitoring to observability. But what is observability? Observability, to just remind, it relies on various pillars, various signals that will help you to fully understand a situation. You're not seeing something and you have to dig down, deep dive in, understand a situation. You have the information, you understand. And to be able to understand, you need logs. We have logs on our code, that's great. Events, so we have environment like Kubernetes that throw events everywhere. But also, in your CI/CD pipelines, you also have events like I'm deploying, I'm testing, I'm doing a release. This is events, useful information that help you to bring context. Metrics, we know, but metrics, we have now dimensions on top of our metrics. Traces is a concept introduced a few years back, but usually when you diagnose or you troubleshoot a situation in production, you look at the traces, you see that there's a step that is slow, but you want to jump down to profiling. You want to see what's actually the origin of the problem, and of course we have exceptions. So the great news, if you look at, if I'm starting in observability world, I will go to CNCF, so Cloud Native Computing Foundation, and I see, oh, there's a bunch of solutions, free, vendor, that's great. This is not really what you will get from the CNCF website. You will get this. And at the end, there's thousands of different solutions everywhere. You try to figure out which solution you're going to pick. Good news, I'm going to help you to find which solution you have to use. So first, OpenTelemetry. This is the reason I'm talking. We're going to jump very deep on this one. It's a standard. So everything which is on the right side for you, no, left side for you, it's the standard, so OpenMetrics and OpenTelemetry is a standard. On the right side is the tooling. So there's toolings for logs, for ND, and bit. There's tooling for metrics, you know them. And there is also Grafana, which is for more visualization aspects. So now you have the layer, so let's jump in OpenTelemetry, our topic. So OpenTelemetry is a standard. So at the end, we have the ability today to include libraries, and we will produce measurements, metrics, traces, and more, in a standard format. So which means the future is we don't need agents. I don't need to use a vendor like Dynatrace or New Relic or Datadog and use their agent anymore. I can rely on a vendor agnostic approach where I produce my signals and I send the data back to the vendor. So in OpenTelemetry, there are two main components very important. There is the instrument, so you build signals out of the code, so you have music coming out of the code, and then to be able to get the music properly propagated in the audience, you need an amplifier, and the collector will be an amplifier. So with the amplifier, you can put some effects, you can modify the sound, you modify the signals, and you can also amplify to send it to, I don't know, Dynatrace and Kafka. You have the options to send to several sources. Currently, the project, which is open source, by the way, it's the second CNCF project. Do you know which is the biggest CNCF project? Don't be shy. All right, it's Kubernetes. Just after Kubernetes is OpenTelemetry. So you know how much the adoption of Kubernetes is currently in the market, so you can realize that this is going to happen very quickly on the market, so you should be aware of it. So in OpenTelemetry, there is various pillars of observability that is covered. So traces is there since 2 years now. It's stable, you can rely on it, you can use it, feel free to use it. Metrics is mainly stable in most of the language, I would say. There's few language which is still in alpha release. Logs is going to be available in next year, beginning of next year. And continuous profiling, the specification is on the way. We should have it probably end of next year or beginning of next year. So how do you produce measurements? For this, you need obviously a couple of things. So for this, we need to inject an SDK in our code. So there's the manual approach where I have the library, and from the code perspective, similar to logging, I will decide what I want to produce in terms of metrics or traces. But you usually don't start for the manual approach. You have the automatic approach where you're going to load the application, and when the application is loaded, we attach an agent. And that agent will instrument well-known framework. So today we use different framework in different language, so Spring, or Java, or Express, or Flask. I mean, there is plenty of different framework on different language. So those will basically instrument those frameworks. They're not going to instrument by surprise your code if you don't use the framework. So if you don't have any framework in your code, you will have to go manual. Then if you do the instrumentation, there are a few objects important. So you have the OpenTelemetry API SDK that holds everything. And then inside of that, you will have a trace provider that will need to be defined. And there are a couple of settings required. So the span processor, will explain what it is in a few seconds. The sampler, the exporter, so where I want to send the data, and the resource. The resource is like the identity of the service. And you have the propagator status. So the span processor is a critical element because it will determine how the communication will happen. So two types of span processors available. One is simple span processor. Every time I end something, I will send it. So basically, it's great because it's going to be live telemetry data. So if you want fishing for live live information, that's great. Second one is batch span processor. As you can understand, if you do live, lots of communication going on, lots of network consumed, so maybe it's not optimized. So batch span processor is the most recommended one, where you're going to publish measurements, they will be pushed in a batch, and that batch will be sent every X seconds. So less live data, but at least you have the data. The other one is sampler. So sampler is a concept of deciding what I want to drop and what I want to send to the observability backend. If you use vendor today, Dynatrace, we are controlling our agents, so we decide how much data we need to help you to troubleshoot. In OpenTelemetry, it's not the case yet. So you'll have to define it manually. So there are a couple of samplings. So we have always on, where 100% of whatever you produce will be sent. So usually it's great, but it's very expensive. The other one is like, no, I want nothing, always off. Parent base is great for dependencies. So here, for example, service B. Service B is called by service A, so it's going to be a child. So I will configure it as a parent. So I will only send details once I'm being involved in a transaction. Trace ID ratio, I define a ratio, a percentage of trace or metrics I want to push. Very simple. And last, you have a combination of parent base and the other, so I'm not going to describe everything. But what's important, depending on what you define in terms of sampling, you can have less or more details. So here, example, I have some couple of ratios. So 50% of service A, service B 25, and so on. So if I want to have a pure end-to-end trace from A to E, and have 1,000 requests coming in the systems, if I do the math, I only have one trace, which is quite low. So you see that the sampling is very important because it will determine how much details I will have back when I need it to troubleshoot. The other concept is trace propagations. Trace propagation is, you should not be aware, but something which is really important is that when you build a trace, if I start a trace from a service A, I know the context is my code, so I can pass the context to the various methods that are being instrumented, but then suddenly I call the service B. So how can I make sure that the context is being sent over, so down the trace continue to the backend? Well, this is where propagation happens, where before the service A is calling the service B, it injects the context, and then the service B, when it gets the call, it extracts the context, so then the traces continue in your environment. Why I'm telling you that? Because there are different trace propagators in the market. So basically, if you don't speak the same language, then you're losing the details. So there is B3, which is open tracing, and there is the rest, which is open telemetry. W3C is all the open telemetry. So if I have an open telemetry and B3 on the same environment, then I'm not talking the same language. So I won't have that details. I'm missing the details. So there are a couple of components like ingress or service mesh. They are using B3. So if you use open telemetry and ingress, you won't have much details. They are working on improving it. On the metric side, I'm not going to do too much on this. You have a meter provider, so it's going to be the main object that will define how you're going to build metrics, and you will define meters. Meters will be a name, a description, a unit, a metric. And then inside of that, you have an instrument. Instrument will have a type. It could be a counter, a gauge, histogram, so similar to Prometheus. And this is where you're going to add the values. And similar, once you produce your metric, you need to send it somewhere else, so use an exporter to do that. There is a concept in OpenTelemetry which is fabulous. It's called exemplars. So imagine, I'm producing some trace in my code. They are in the same context. And I have a trace ID, a context related to my trace. And suddenly I build a metrics. And then I build some logs. If you do so, then every single signals are attached. So I'm doing some troubleshooting. I'm looking at trace. Oh, it's slowed down. I want to look at the CPU profile of that user. Boom. I can do that. I can filter the CPU usage of that particular user. This is the notion of exemplar. So this is very powerful. Again, things will be improving in the future, but this is a great way. One of the components that is crucial, I barely mentioned it, it's the collector, the amplifier. You will see that collector is a critical component, and you will have to manage it in the future. So you can deploy the collector in various ways, agents, so it's going to be sitting close to your code, so very optimized because only local host communication to push your telemetry data. You have the host, so it's more in Kubernetes. You will deploy it at every node of your Kubernetes cluster. And last, you have the gateway, which is a big bang service that receives everything. This is not recommended. So if you're using maybe an old technology, maybe you have to use this, but this is not going to be recommended. When you use collector, usually you not use one collector. Most of the customers today, they have thousands of collectors that they have to manage. So usually you split the processing work of your traces and metrics on several components. One locally, so here I have the red components that will be a collector sitting in a sidecar. I do some pre-local processing, and then I send back to another collector that will do an extra processing, and then I send it to my backend. And the great thing here, if I do that type of design, if I need to switch tool, I use Datadog and I want to switch to Dynatrace, obviously, I would have to just change one spot, the green boxes, and that's it. So less maintenance at the end for the users. The collector is similar to log agent processor, FluentD, FluentBit, I don't know, Logstash, maybe you know those. When you do use those products, you have to build a log pipeline. Here it's the same thing, you have a pipeline. So this is the language on the right side, where you receive some information, you process, you modify the data, and then you export the data somewhere. Side of that, you have extensions. Extension is a way of increasing features on the collector level. The color is different here in that slide because the extensions has never access to the data. It's something that is never access to the metrics, to the traces, so it's a bit specific component. So now you have in mind most of the main components, but you see that when you build telemetry at the end, keep in mind you use it for automation, for DevOps processes, but also when you are facing a big outage in production. So the quality of data that you produce is very important. If I have a metric, that metric I need to be able to split it by server. Let's say I have a CPU. If I have the average CPU of my environment and I have thousands of servers, I won't be able to understand where this CPU is being consumed. So I need to be able to split by server, by zone in the cloud, by... So the notion of dimension is very, very important, to bring the extra context. Traces is the same thing. If I don't instrument well, maybe I have some gaps, and I don't know where I'm spending time. So I need to have efficient and good visibility on the details of a given transaction. You also have the notion of events. When I build a trace, I can send events. Events are very important. Let's say I'm doing a paying transaction, where first I need to reach out to the paying platform, then it's been acknowledged, then I can go further. So there are several steps in my transaction, and so I can create events. And events are very powerful, similar when you have to troubleshoot. And last, signal is logs. You know that if you produce logs and there is no context, you have just a text line, which is very hard to utilize. Adding context to the logs is very, very important. Because at the end, when we have that telemetry data, we are going to potentially have a murder. Our server will be down, killed by a bad user or a bad bug. So we will have to profile. We will have to investigate. And so if you don't have the context, you're not able to connect the dots. The tracing challenge today is related to the fact that we have two personas. We have on one side, we have the producers. And on the second side, we have the consumers, the one that will deal with data. And the problem is that the producer usually have different objectives when you use telemetry data. If I use telemetry data in my dev environment, I'm fishing for live data. So to do live debugging, for example. So I'll probably use simple span processors. And I want to have 100% of my traces. So we use always on. And the other thing is sometimes you're looking at your service, you have not a good broader vision on the entire environment, so you do things related to your small context, so you don't necessarily add the right context sometimes. So that it happens. And the other thing, when you do tracing, let's say I'm producing a tracing, I did some auto-instrumentation, I'm so proud, I see in the UI, I got my details, and then you try to troubleshoot, and then you see, oh, we're spending time on that blue bar. Okay, what is it? Well, I think it's not well instrumented. So if you re-instrument it, now I at least have more details. So for example, checking that the details that you're getting is efficient and meaningful is important, because otherwise you won't be able to be efficient when you have to use that data. The other persona is the consumer. The consumer is obviously looking for having data, enough data, but not paying too much. Sorry. Because if you, let's say, send 100%, of course we're going to deal with data, but the building and the licensing that you will have to manage is going to be very expensive. Imagine it's going to be 1 terabyte per minute of data per metrics, then 1 terabyte per minute on traces. So if you can manage by yourself the storage, no way, no problem, but keep in mind it's going to be very, very, very expensive. So you need to figure out what level of details do I need for the right cost. Then, because I'm dealing with thousands of teams, I need to write dashboards with providing the right information that will for everyone. I don't want to have a building dashboards for every single team. It doesn't make sense. I have more interesting things to do in my day-to-day job. So I need to adjust the instrumentation, so I need to be in contact with the right people. I need to make sure that we have the right context. And also I need to be able to build alerting on those components. So how can you continuously improve tracing? Usually you start simple, and then you continuously improve. So the first reaction is that most of the network components, so ingress, service mesh, if they're using W3C context, they are producing traces. So if I enable the service mesh, all the services that go through a service mesh, I will have traces. So I can see all the communication requests going back and forth. So at least I have this network map. So that's a good start. At least if I know that I'm spending time in one component, I will be aware of that. Then, to add more details, I can enable automatic instrumentation. So then I know I'm going in a given service, and then I have all the traces generated by the framework. So I have extra details. And last, if I'm missing something crucial on a given business component, yeah, I don't rely on a vendor library, so I can jump into the code, ask the developer to instrument, and I will have the detail that I need. Same thing for metrics. You have the luxury now to say, hey, I want to create a business metrics of my payment service to track some meaningful information for my company. It's agnostic. You can do that now. One thing which is unclear is the which is unclear is the tracing coverage. Today, we instrument, but we have no clue on how much details we have, how much services is being covered. So there is this notion of tracing coverage. We don't have it. Something similar to testing coverage. This is something we should keep track in the future. There is no standard. But we can imagine to have a rule saying, okay, so I'm going to count all the requests that are in my environment that has the W3 tracing context. If there is a tracing context, then it means that there is some tracing. And then I divide it by the total number of requests I have. So at least I will have a ratio. So technically, it works. But keep in mind, sampling goes in the picture. If I have the sampling happening where temperature data has been dropped, then there is no trace ID. So I don't know if it's a non-instrumented service or if it's a service that has been just sampled at that moment. So again, there is no recommendation as of now, but I think with the community, it's open source. We can basically, everyone can contribute here in this room, find a way of improving, find a way of helping to testing those type of observability. So there's a lot of things that is still needed for the big organization to utilize it heavily. So we have to work on together. So the takeaway. So first, make sure that in your future that your code is agnostic, that your environment are agnostic. Don't rely on vendor library, because you're going to be locked to that vendor. So by having open source or an agnostic library, at least you are free to move on without any effort. Observability, of course, for producing tracing, metrics, events, everything that can help you to troubleshoot and be more efficient in your day-to-day work is important. So putting observability everywhere, it's recommended. And then continuous, like I say, start being smart. Don't instrument manually directly. Do the automated. Use what could be produced in a very efficient way. And then add last mile in manual if needed. And if you're starting from scratch, a new application, you just have to need and ask your developers, you're producing logs, why don't you produce traces and metrics as well? So it's easier when you build a fresh new app. So there is plenty of other content I can talk about, but I am almost at the end of my talk. So I will recommend everyone to check out my YouTube channel, to subscribe to the channel, to watch the content, to send me some feedback so I can improve the content. There is plenty of content related to OpenTelemetry, to logging, ingest, blah, blah, blah. So check it out. It's free. It's out there. And the idea is that for any open source product, if the adoption is here, then it's a success. So let's make this project a successful product.
Now, we have a few minutes for questions. So I don't know if anyone wants to volunteer with the first question. There we have one.
Is there any plan for... Hi. So are there any plans for implementing conditional sampling? Like being able to, when some condition is met, then sample that request?
It's a great question, to be honest. So there is a specification on the way from the OpenTelemetry called OPAMP. OPAMP is a way of managing OpenTelemetry fleets. So what is an OpenTelemetry fleet? In fact, it's not OpenTelemetry fleets, it's agents. You help to manage agents. So OpenTelemetry collectors are agents. So you can, because there is a pipeline, I need to upgrade and maintain that. There is the SDKs. I want to switch the sampling decisions lively. There is also FluentBit, all the log agents. So there's plenty of components that we manage on day-to-day basis, and this protocol is aimed to basically all the agents, all the collector will run, spin up, connect to a server, and the server will be able to maintain it. So get temperature data, the health, but also update the settings. So if I want to lively change my sampling decisions based on events, in the future, with that protocol, we can imagine, so Dynatrace is working on that. In the future, it means that Dynatrace will be able to control those telemetry agents and say, hey, now I want to have more details, or no, it's fine, you can drop it. It's sampling, giving the complex problem of sampling to the hands of the user doesn't make sense. All the solution vendors have been working to improve it from a smart way, so I think this is the future, for sure.
Anyone else? We have time for another question. There we go. Yay.
Based on what you mentioned and the examples you gave, it makes me feel that everything is prepared for Kubernetes, but it should be available also if you are not running on Kubernetes, right?
No, it's designed for everything. It's just the way you can deploy it, it's make your life easier in Kubernetes for sure, but you can use it on any technology. It's not sit to the technology. And also if you use Lambda functions or serverless architectures, today there are a couple of observability solutions like Dynatrace. We can inject our agents before it starts the functions, but sometimes it's not possible. So here I say, why don't we use OpenTelemetry for this piece? And then I will have telemetry data out of those serverless or functions.
Thank you.
Okay, so closing up, thank you so much, Henrik, for your talk today. Right now, we're going to make a coffee break. We'll expect you to be back around 12:20. Switching back to Spanish, vamos a ir a un corte, a un coffee break. Los esperamos cerca de las 12:20 para seguir con la siguiente charla con Daryl Fares. Tengo mal el horario. 11:20, perdonen. Nos vemos en un ratito. Muchas gracias.
Changing technologies and user behavior.
This is, there we go. Okay, so we will resume with the event, with the conference. The next track is called Quality Engineering, Reconciling Faster Development with User Expectations. Welcome Daryl to the stage. Daryl is from New Orleans and is the Solutions Engineer Manager at Mabel, a low-code quality engineering platform and an Abstracta partner. Welcome, Daryl.
Thank you, Paz. Thank you, everyone. Buen dia. It's so nice to be with people again after so many years in a pandemic. I was just out there. I saw crowds of people all talking to one another, and it was a beautiful thing. So I appreciate all the folks who are coming in now. I'm sorry to interrupt your conversations with a talk. My name is Daryl. I've worked in tech for over 20 years. I have little hair left after it, but it's been a lot of fun. I love software testing. I did not start my career in software testing. I started it working at an internet provider, maintaining lots of Solaris boxes and modem banks, and then stayed in back-end and infra for a little while, and a friend reached out to me and said, hey, I'm hiring a tester. You want to come work with me? I said, I don't even know what that is. And she said, I'll teach you. And so that's how I ended up in testing. But more than anything, I really enjoy things that work properly, whether that is software or anything else. So jumping in, I have a lot of content, so I'm going to talk really fast. I hope that's okay. In tech, right, everything changes constantly. In the last maybe 10 years, the word transformation has been spoken a lot, right? Agile transformation, digital transformation, DevOps, technology, anything anyone can put in front of transformation, we've said it. And I think one of the new terms that we're seeing come to market is quality engineering. And so the main theme for my talk today is kind of a little bit about what quality engineering might be. I think a lot of us are still figuring it out, and kind of what it means. So historically, and I think still today, we're trying to figure out how to get software, how to get value into our users' hands as quickly as possible and in the nicest way as possible. DevOps did wonderful things for developers and ops teams. We're able to spin up infrastructure like that. We don't have to wait for physical servers to be shipped to us anymore. We don't have to manually build software. We don't have to FTP up software onto a server anymore at the worst. So lots of great things happened. QA, some say QA is a bottleneck. I think we're just very attentive to the things that we do. And so what you kind of see sometimes is everything else has sped up until we get into the testing phase, and then things slow down for a wide variety of reasons. And then it slows down that trickle of value that's getting out to our customers. Ideally, we'll have this nice continuum of change coming in, testing happening, value getting out, and it just flows. Sounds lovely, really hard to do. I listen to a lot of other talks. I go to a lot of conferences. I read a lot. And I read a lot about quality engineering lately because it's kind of the next big thing, we're told. And I've come to this disposition that I think quality engineering is more of a state of being. I think it's when we take a lot of what people call best practices and put those into place, things we've been hearing for the last 10, 15 years. Once you start doing those things and you do them well and you do them iteratively, you kind of arrive to this place where all of a sudden, instead of everyone doing this, things start happening like this. I think that's what quality engineering is. But it's not just process, it's not just tooling. People are behind this. People in teams, And those people and teams have behaviors. Those people and teams have to adhere to process, hopefully process that is capable of changing and adapting. And there's culture behind this. We talk about DevOps culture, but there's also the culture that is embedded in the teams who we work with and how we talk about software, how we talk about quality. And all of these things are related to quality engineering. In companies where testing as a discipline, testers as people are valued, we see higher customer satisfaction in the applications that they use. This isn't teams that are really good at automation. These are teams that are really good at delivering quality customer experiences. Doesn't have to be automation, doesn't have to be manual testing. Hopefully it's all of the above. But it's pretty remarkable. And I think that those of us who are testers, we enjoy feeling valued, and we enjoy when people appreciate our work. And I think that shows up in the products that we build as well. This is one of my favorite stats that I came across a few years ago. 32% of customers will leave a brand after a single experience. I'm one of those people, admittedly. It's important, right? Lots of times we have different applications that we have various levels of dependency on, right? I can open up my phone, I can use Twitter. If Twitter doesn't work one day, I'm fine. My mom has a pacemaker. It's connected to a mobile network that reports back everything to her doctor. If that breaks, that's a big deal. So I'm really glad they have people testing these things. So thinking about quality assurance, what moving to quality engineering might look like, I think part of it is making sure that we're building quality in throughout our software production process. So that's everything from how we talk about quality to how we practice the disciplines surrounding that we do, whether that's performance testing, whether that's user testing, right? Just people talking to people. Ensuring quality across the customer experience. This is how maybe one day I will not be one of those 32% of users who leaves for another product. Ensuring quality across the customer experience is really, really important. People interact with our products through various interfaces. And some of those interfaces are better quality than others. Getting consistency there, I think, is really important to focus on, and especially validating functional and non-functional attributes. I know there's a really great performance testing community here. Before this, there was the Whopper, and there are a number of talks happening around performance testing as well. This is also things like accessibility testing. In the United States, and in other countries as well, there are now laws that apply to software companies. So if your application isn't accessible based on certain standards, you can be fined. And this is happening more and more frequently now. So there's also a business reason, not just an altruistic one, to focus on this. And using data to drive continuous improvement. This is really hard for some people, and I think one of the problems is that, at least in modern software companies, I think some of us are drowning in data. We have a ton of data at our fingertips. We don't really know what to do with it all sometimes. One of my favorite kinds of tools are the ones that track a user's journey through our application. And when I see teams implement something like that, it's this wow moment, because all of the user stories and requirements that we write, then you start looking at what people are actually doing in your software. It's usually not what we think it is. And I think being able to bring that awareness to the way that we practice our craft is really important. It helps us do a better job. This is a model that my company came up with. And I don't exactly like the graphic very much, because I think this looks like a linear growth chart, and I think of this as more like a giant Venn diagram where we have to do all of these things. We have to sprinkle sugar everywhere. So even though testing manually is at the bottom of this list, it's more like this is table stakes. We have to be doing manual testing. Automation does not make manual testing go away. Manual testing is really important for things like experiential evaluation of our software. It's very important. Paul over here was telling me about an experience he had trying to scroll through a mobile emulator, and there was tremendous lag in that action, and then it crashed. I don't know if that would have happened if we were automating that. You know, maybe it would have worked at that layer. But when a user is actually doing it through a different kind of interface, who knows what can happen? We have to know these things. We do need automation. Automation helps us do the dumb stuff faster. People have amazing brains. We have amazing experiences. We all use software every day. I see phones everywhere in this room right now in people's hands. And we have to make sure that all of that stuff works too. Once we get kind of the functional stuff and the table stakes, we also have to make sure that that's integrated throughout the process. So for years, right, I've been fortunate enough to work in companies where developers generally have good unit testing discipline. That's great. Unit tests can't find everything. And then I've been on teams where, we have a ton of manual test cases. We have this fleet of manual testers, and they're doing this stuff iteratively. But then there's not enough time left over to just take a step back, look at this holistically, and say, I think this feels good. I think our customers might like this. It takes time, it takes some space to be able to have that. And then non-functional quality, right? I just mentioned accessibility. There's performance, all sorts of things. These things matter because it leads to what the actual experience is. I can click a button and make something do something, but the way that that something happens is also very important. And then using all of the data that we've gathered through various systems and using that to inform how our process, how our approach might change. Some teams I've worked on, they sort of define like a theme for a particular quarter, like, hey, this quarter we're going to focus mostly on this. We're still going to do this other stuff. And they decide that based on the data that is brought to them. And I think when you do these various things, and the amount of each that you do is going to be different for any context that you work in, right? Applications do different things. Software is a great big world. So knowing your context, I think, is also very, very important. So having said all of that, where are you? Where are we? Collectively, but individually in our own companies. This says start with an assessment. I think another way of saying that is start with a conversation. We have to talk to one another to understand what each other's challenges are. What do we think is going well? What do we think needs improvement? Do you see any patterns? So problems, right? They can't really be solved until we quantify them. I see problems everywhere. I'm a tester. And, they're not all very important. Some make me more angry than others, naturally. But knowing how angry I get, right, is part of that quantification. Understanding your team's core strengths. Our companies are made up of all kinds of different people who come from different backgrounds. It's a beautiful thing. I think one of the things I really appreciated about Eric's keynote earlier, if you were here, was making sure to focus on things that people do well and not necessarily focusing on all the bad things that they might do, things they're weaker at. People have strengths, and all those strengths are very diverse and different. So as managers, I think our role is to identify, what's the best work that someone could possibly do, and then how do we extract that? How do we get them in a place where they can do their best work, where they feel empowered to do that? And then there's our tech stacks. Does your tech support your goals? When I first started doing automation, I think when a lot of us started doing automation, we were using something like Selenium. Great, but it can't do everything. And so sometimes when we want to expand our horizons, we have to start identifying other methods and other approaches in order to meet the requirements that we need to, build good software. And so then you have to figure out, thinking about all of these things, right, we're all talking, where can we make an impact? So thinking about things that we can do more tangibly, quality, right? Quality, we can all, as testers, we can all be very passionate. We can have the best intentions, but if our organizations and the companies that we work in don't support this, it might not work. So, and I think that's been something that I've seen improve dramatically, especially over the last few years, because we've solved so many other problems that testing and quality in general is kind of now one of the final frontiers to really realizing like the true vision of what DevOps culture could be. We have to make sure that the things that we're doing, of course, are manageable, maintainable, and most importantly, meaningful. So, as teams, right, we should be talking about testing and quality. We should be talking about how we want to test things and how we think risk might be perceived before anybody starts writing code. We should be doing this in the design phase. We need to make sure that everyone who has some sort of stake in the product that we're delivering has a seat at the table. And some of that requires teams to open up a bit more. This isn't just a product manager dictating, this isn't just a developer dictating. These are conversations that we all have to have. Please, devs, do unit testing. Please. We have to make sure that we're testing the right things, and the right things might be different at different times. So, business risk, right? Naturally, we want to do that. But more importantly, we really want to focus on the customer experience. We need to preserve and protect our brands as companies as well, right? 32% of people leave after a single bad experience. One of the nice things about certain tools is that it makes it fast, you know, to build up test cases, manual or automated. It's great. Also makes it really easy to get rid of them when they're no longer useful. So don't just keep your test suites and everything just building up and building up and building up. Focus on what's actually valuable. Maintenance is terrible. It eats us alive. Automated testing. Automated, right, we've been talking about shift left for a few years. I think sometimes forgetting that our customers are over here on the right. So we need to make sure that not only are we testing early and often, but we're also testing throughout production as well. Different infrastructures host our applications at different times. So it's not just the application code that impacts quality, but also how we host and serve that too. Making sure that we can do all of this efficiently is really important. This is why I feel sad when I talk to people who are so laser focused on requirements and they think that's the only thing that exists. Yes, we need to make sure that the requirements of the applications and products that we design, but there is more. I heard a noise, I thought it was this thing. And of course, right, making sure that we're testing throughout the dev cycle. Monitoring, oh my gosh, we can learn so much. I worked with a customer who was having an issue in a very, very, very large company. Lots of microservices, lots of shared components across teams. They were having an issue with just having these bugs get out to production with a really large blast radius. And so the first solution to that was every time they would have a release, they would get maybe 50, 60 people on a conference call together. It's good to circle the wagon sometimes, but someone then did the math on, well, how much does this phone call cost? Because there are some pretty important people on this call, right? And it was $1 million phone call that they had every couple of weeks. And so they said, well, clearly we need to solve this in a different way. So lots of considerations to think of. Non-functional quality. I love that this is kind of having its moment right now. At the last, I don't know, maybe 4 conferences or so that I've been to, there have been more talks around performance and accessibility. There are more vendors in the expo rooms talking about performance. It's wonderful, right? We have so many horizons to explore. Get rid of tests that are inefficient, find new ways to approach problems, and make sure that accessibility isn't something that you kind of test after, right? I think accessibility and performance are going to be one of those, well, performance already is, but accessibility is going to be one of those things that we're going to start thinking about earlier and more often in the dev cycle as well. Because again, businesses don't like to get sued, and while it's wonderful to have accessible products and accessible websites from an altruistic perspective, it's money that really makes the businesses start supporting these kinds of initiatives. So honestly, as testers, sometimes it's our job to make sure that the business knows what risk really means. Oh gosh. I'm not going to read all of these. I want to leave time for questions. But continuous improvement, right? Using data in the right ways. Data is a dangerous thing. It can be misinterpreted. It can be misapplied. This is why we can't do this in isolation. You can't just have your one data analyst over here analyzing everything and then producing something. You end up with bias. So we have to make sure that there is diversity in the data and there's diversity in the interpretation of the data. I think that's really the biggest takeaway from over here. And if we do all of these things, another phrase we've been hearing a lot, right, is cultures of quality. It sounds so nice and warm and fuzzy. And they are. But ultimately, if we start taking a more multidisciplinary view or a wider perspective on quality, and you start involving more people, again, not just engineers, but business folks too, all of a sudden people start appreciating things a little bit more. And it's a conversation that has to continue. It never ends. And hopefully one day we can all get to a little model like this where we're just writing code and writing features and pushing them out and they work and our customers love us and they're happy and they become advocates for our products. And opportunities abound. So again, kind of summing it up, right? Try to understand where you are, but also where you need to go. People, process, and technology, we've all got to get there together. If you need to augment your tech stack, if you need to bring in other tools, other different kind of analytics products, right? Figure that out, talk about it. Data actually does bring perspective. Embrace new opportunities for collaboration. Look at all the people in this room. I loved seeing everyone out there just talking. It's one of the best things we can do to influence quality in our products. Just talk. Get the whole team involved. Talk before you do anything, please. So key takeaways, quality engineering is evolutionary, it's multidisciplinary, it's not just requirements, it's not just stories and making sure all of these things work, it's not just acceptance testing. We have to focus on customer experience, right? We don't decide if we have a high quality product, our customers do. And another little analogy or cliche here, right? Testing is a team sport is one. I think if that were true, I do. But quality engineering really is the Olympics. It takes a bigger team. It takes folks practicing different arts, different practices, and you put it all together, and you get a nice little culture of quality. Muchas gracias a todos.
Thank you so much, Daryl. Now we have 5 minutes for questions. Anyone want to go first? Want to volunteer? Don't be shy.
Creo que le podemos preguntar en español. Right?
También, sí.
Anyone? Come on.
I have a question.
There we go.
Pregúntame.
As a quality engineer, how do you have any advice on how to influence and try to help in this idea of having the whole team involved in quality that you mentioned?
Yeah, I think, not to sound a little repetitive, but start talking to people who are around you and find people who are interested or concerned in your midst across teams. Those people can help be, I say, it's nice to be a soloist, if you're singing, but a chorus really makes a bigger impact. So the more advocates that you can find around you who share a vision of what something better could look like, I think can really, really help. It's hard to do it alone, and I think that's why collaboration is so important, and collaboration can mean lots of things. But I think being able to identify people around you throughout your organizations who also care about how customers experience our applications, find your family in that regard, and good things will happen.
Thank you.
Hola. En español o en inglés. In the graph that you show about the quality maturity, like manual in this one, in which of these state of phases you can start thinking in non-functional attributes like performance, security, accessibility? Where do you have to stay to start thinking in these kind of things?
I think that, just in general. In general? It depends on your context, right? Sometimes certain things have a higher priority. If I work in healthcare or insurance or banking, at least in the United States, these are regulated industries where there are specific laws that have to be followed. And so in that case, you're sort of forced to start talking about some of those attributes as well. If that's not the case, I think sometimes it just takes someone to start the conversation. Sometimes it takes someone to make an observation, right? And they're like, hey, I noticed that the app seems kind of chuggy, or it's a little slow. Anybody know why? So QA, question asker, right? Sometimes you just have to start asking questions. And then other people start, like, oh, you bring awareness to others. And that, I think, is how you start then building some consensus to start approaching new problems, right? Because again, it's hard if you're just one person. And some of us are, right? Some of us are teams of one. I've been a team of one many times. And in that case, right, then you really have to kind of take that on yourself. But you have to be brave sometimes and start some hard conversations. But again, I think one thing that can really help there is data, right? How can you get something that other people trust that might be outside of you to help substantiate your case? Hope that helps.
And requirements.
Okay, I think we have time for one more question. Anyone? Want to go again, Fede, maybe? No? Okay. Okay,
right.
then we will finish up this track. Again, thank you so much, Daryl, for participating in the first edition of the Quality Sense Conference. Thank you.
Yeah, many thanks to Abstracta as well. This event is wonderful. It really is so great to see so many people, both in this room, the other room as well. What a great conference. It's so good to be here with all of you. Thank you so much.
Thank you so much. Right now, in 5 brief minutes, we'll be starting with the next track, using test automation to enhance observability with Andy Hohener. So we'll be right back. Thank you.
In fact, with the adoption of modern development practices,
welcome Andy. Andy Hohener is a senior software engineer and test at GitLab. So welcome, Andy.
Thank you. Oh, the wrong window is showing. You don't need to see. Okay, let me get this straightened out. Sorry about that. What else do I got up? While I'm doing this, since I forgot to send in a bio for them to introduce me. So as she said, I'm currently a senior software engineer and test at GitLab. I have been bouncing back and forth between testing and operations for over 20 years. Okay, let's see what will show now. We'll just parallel my screen. There we go. So I've been bouncing back and forth between ops and testing for 20 plus years. So I've been championing DevOps principles since well before the term was even coined. So I'm going to be talking about using test automation to enhance observability. Where this started was, there was a time where I was working as a tester at a startup. It was a fairly small team, 2 testers, 7 developers, and 1 ops person. We were building and maintaining an application that had the equivalent of several million people sending tweets to it every 5 minutes. So it was we were basically DOSing ourselves every 5 minutes. We had a target of 99% uptime, mostly because if we failed that, we would fall behind and never catch up. We also had the requirement that no story was done unless it was tested and automated. So we were generating up a large number of automated tests. We actually had more lines of test code than application code. So with so few resources, so few people, I started trying to think about, okay, how can I maximize the value that we're adding to the product? And since we're generating all these automated tests, can we increase the value add of these tests that we're adding? You gain value from the test every time it's run, and you learn something. If you just run it a whole bunch of times and don't learn anything new, that's wasted effort. So I started looking into ways that I could increase the value we got from every run of our tests. First step, okay, we're running them in just our test environment. Well, let's see if we can run it in our staging and our production environment. That's great and good, but they still, over time, fall down to the regression path and don't really provide that much value after that. So then I started looking at our observability tools, and I'm going to go through a quick overview of a way I look at observability, and I know Henrik is going to wince at my definitions, but what is observability? From Wikipedia, observability is the ability to collect data about program execution, internal states, modules, and communication between components. Honeycomb says observability is the ability to fully understand our systems. In control theory, observability is the measure to how well internal states of a system can be measured from the external. To me, observability is the ability to ask a question about your system and have the data to provide the answer to that question. And how do you go about doing that? Well, you wind up taking all your various observability sources, metrics, logs, traces. You put them in a big data lake, and then you go fishing. Hey, do we have any 503s? No, good. How long does it take us to log into our, how long does our login page take to load? Hey, we got some timing numbers. Did we have any 404s? Yes, and hey, there's the stack trace. You gather the information, and then you can do lots of things with it. You can create dashboards, you can create reports, you can create alerts. Often people create SLAs, SLOs, and SLIs around that. For those who don't know or aren't completely familiar with SLAs, SLOs, SLIs, and come on. I tend to think of it as SLA as a contract. We need to have 3 nines of uptime or else. SLOs are your milestone. It's your milestone, 99.9% uptime. The SLI is where you are currently. We're currently 99.1. Hey, we're still good. Now, observability has been helping testing since pretty much for as long as it's been around. It is information. You can use that information to understand how your system works, what sections of your application are heavily loaded, what sections are not loaded. You can use that to guide where you need to focus your testing. It's also information about how the test worked. If you're not testing something of, hey, our login page loaded and there's a green login button, you don't need observability of that. But if you're testing, hey, our application has a button that restarts the application, and when you click that button, all the back-end jobs need to finish out their jobs and then shut down, and the back-end servers need to shut down, and the front-end servers need to shut down, and they spin back up in this order. Observability gives you that information of, did that happen in the correct path? It also gives you information of what went wrong. Hey, I just loaded a 404 on my web page. Your observability's got the stack trace and the other information that you can use to figure out what went wrong. Testing can also help observability. Observability is great at detecting, hey, something happened in the system, and give you some information about what happened technically. But, hey, my search page is loading 2 seconds slower than it used to. Is that because the release we just deployed changed something that caused the search page to load slower? Is that because we're an e-commerce site and we just took on a new vendor which doubled our inventory? Or did our customer change some parameters on their search page, which meant they used to only be pulling a small subset of our products, and now they're pulling the entire thing? You don't necessarily know based off of the information that observability gives you. If you can feed your test scripts in, that removes a lot of the variables. You know precisely what data your scripts are dealing with. You know precisely what workflows your test scripts are doing. This is, of course, assuming you're not dealing with dynamic test scripts built to deal with dynamic data, but that's a completely separate issue. It also opens up the door for the thing I find most interesting is, what do your customers really care about? Particularly, and at this point I'm talking about things with the UI. They don't really care that this page, your search page loads in 2 seconds or your login page loads in half a second. They care that they log in, they go through 4 steps to get to that search page and are able to do what they need to do. If you push out a patch that reduces the time to load your search page by 2 seconds, but it adds 1.5 seconds to 2 of those intermediary steps, those 4 intermediary steps to get to that search page, that user's experience has actually gotten worse, even though you've made the search better. So, if you can start feeding some of this information, you can start wrapping SLAs, SLOs, SLIs around the things your customers really care about, their workflows. Your test scripts, you can mimic the user's workflow in your test scripts and feed that information into observability. Now on to the fun part of this exercise, the demo. I've created a simple repository up on GitLab. Gee, surprise, it's open to the public. Anyone can go look at it. Where's my mouse? And here's the code that I'm going to be showing you. tiny. Gonna blow this up. Let me actually take a step back for a sec. Go back here. I'm losing my mouse. There it is. For this scenario, I'm just actually using a simple Selenium script, feeding information into sumo logic, just because it was fast and it was easy. Yeah, let me get it logged in and then I will. So I'll start with the outside in. This is a dashboard that I just, and it is zooming it back in whenever I zoom it out. This is data that I've fed in using what I'm going to be showing you in the script in just a minute over the past couple days as I've been working through the application. So I've been able to fairly easily just graph the lines of the data points that I'm gathering, displaying it in a numerical fashion, not the most complex or overly intelligent graph, but just showing that the data is there, it's accessible, you can mine it. If I had it in the actual production one, I could then correlate it to, I've got this nice little jaggy section here, which the performance tester in me really wants to go diving into. But I could map that to, how the servers were functioning at that time. Create a query that cross-tabs that all together. And it's actually pretty simple and straightforward on how this works. I just simply created an HTTP collector in sumo logic that I just gave me a URL, I just pushed the information up to it. There are lots of other ways to deal with collectors. Henrik will probably regale me no end, but like I said, quick and easy. And when I start showing you my code, I will admit that. My coding technique is I make the simplest thing that works, and then I make it faster, better, more efficient. This is definitely still in the it makes it work phase. So this is the script that runs that data. It quite simply just logs into a URL, loads a couple subpages, and is done. And it runs pretty quickly. I've got it written in Ruby, using Capybara and Selenium. And that was me just doing RSpec. And it will launch and run here for a couple seconds. Of course, it's putting the screen on the other page, so you guys don't get to see my blog post. But there it ran, and it took 17 seconds. Now, of course, the next time I run it, it will take a lot shorter just because the cache has been. See if I can type what. Now, how do I implement that? By quite simply including a library that I wrote, which I will dive into in a moment. If I had access to it when I figured this out, I would have. But I just create a simple logger tool. In the sumo logger, I've got basically, well, total of 4 methods. First one is start, which starts a timing data point. Yes, I am. Thank you. And then I can end the data point. Oops. Let's end push. And then I have a simple method that pushes the data up to Sumo Logic. I can save it. I can run the test again, which will run significantly faster. Should run in about 7 seconds now. As you can see, I've been doing it a fair bit. Yep, 8 seconds. Now it just pushed the data point up to Sumo Logic. Now, the performance tester in me, of course, is not satisfied with just pushing one data point. So, and I'm going to save you guys watching me mangle typing. So, I've got basically every single step instrumented. And once again, I can run it, and it'll take a few tenths of a second longer to push the data up into Sumo Logic. Yes. Actually, it was even a little faster. What does the logger do? Like I said, it only has 4 methods. The initialize is what's called, in Ruby world, initialize is what's called when you create a new instance of an object, which basically just creates a hash. And I'm pushing the values into the hash, and then when it's time to push them up to Sumo Logic, I just read them out of the hash, and up it goes. So here's the start method, which, being a tester, I added an error state that if you try to start an action that already exists, I give you an error. But then it just sort of saves the timestamp, and end has a similar error of you're ending something that doesn't exist. I capture the end time. Pushing up. Here I'm rattling through all of the data points that I captured, putting them into a JSON object to push up to Sumo Logic, and just simply use NetHTTP to push it up. So pretty simple code, and you can just instrument any test you have with that sort of methodology to get data up. And certainly, like Henrik said, you can probably use OpenTelemetry or some other tools as well to instrument it. Now, some gotchas I've found while going through this process. As you saw, I captured everything in metrics because, gee, I'm a performance tester. But you don't necessarily always want to capture everything. You're going to be adding data to your data lake. And data lakes cost money based off of how much data you got in there. And also it can make it harder to find the information because you have more information. So think about what information you need to capture. In my case, I'm just capturing timestamps and the actions. Well, is it valuable to add an extra parameter so you can filter by, hey, this is my login test versus my search test? Or is having the amount of data transferred something that's useful? You can just push data in based off of what's needed, but think about what you're pushing in. Make sure you're pushing in what you really need. Second thing is, make sure that you have a way to separate, if you're pushing into the same data lake as your production observability, make sure you have a way to separate your test data from your production data. Because you don't want your SREs and your devs making decisions about how your application needs to be stood up or scaled out based off of your test scripts. So you want to make sure you can pull that out, particularly. Third item, how often do you run? Yeah, it'd be great to run it every 5 minutes. You get all sorts of useful data. But you're adding load to your system. You could be triggering backend processes to run that normally would only run once a day. You might wind up causing them to run more frequently. You don't necessarily want to do that. So you need to take these considerations into concern when you're adding this sort of instrumentation to your test scripts. Any questions?
Okay, so continuing with the Q&A, does anyone have a first question for Andy?
Don't be shy.
There we go.
It's just about the library that you use. I was thinking, because they remind me of a project that was done in Selenium, where you can modify the core functions of Selenium, where those libraries and way of instrumented will be automatically applied every time you do, I don't know, click or whatever you want to do in your scripts. So we could then enable that more easier to the users. What do you think about that approach? Or would you think it makes more sense to let the tester says, I only want to understand these details because otherwise I will have too much data to deal out of my test?
That was actually a debate that I was having at my last employer, the one Eric was mentioning earlier, where they have a lot of built-in frameworks. They actually have about 4 or 6 different test frameworks that they're using. And we were having a discussion about, okay, how do we best implement this? Do we build this as a add-on that you can just run there, or do we bake it into some of the, they've got a method for login where they just pass in the username and password. Do we bake it into the sub thing so people don't even see, which would certainly make a lot cleaner code. And that sort of goes back to the question of make sure you capture the data you're really interested in. There's some things that I could see like login where it would make sense to just bake it in, but it might also make sense to have the ability to push in an extra data point of, hey, particularly when you go to the thing of thinking about workflows, you can't necessarily predict what the flow is, so it's probably worthwhile having a separate method. So, hey, I want to track login through doing a search on the application, capture that as one big data point, that I want to then wrap an SLO or an SLA around to prove to my big customer that their workflow hasn't been damaged. So having both ways is probably good. Taking into account what information is really useful for me to capture.
So I have a yellow topic. I was thinking, because in OpenTelemetry you have the ability to inject a bagage. So it's like, instead of doing the way you were doing, to inject on every request that you're dealing the HTTP headers. And then if of course the application is instrumented, then this notion of running these tests, this requirement, whatever, I mean, all the details related to test would be then available in the observability solution. So then you can also query and say, hey, give me only the telemetry data related to my tests, blah, blah, blah. So that could be a way also maybe of improving what you were showing us to us.
That would improve too, and that was actually, I was having a discussion my last year at my last company. I was actually in the SRE team that was implementing OpenTelemetry, and we were discussing doing exactly that. Which I think is definitely good and definitely valuable. It does go back to the question of, okay, it detected a change. What changed to make that change happen? Did the data model change? Did the, what search criteria they're putting in change? If you're only relying on the end user's interactions, what the end user is doing will affect your results. So I think that's definitely valuable. I mean, certainly that would be very great for when you're trying to figure out, okay, how are the end users using the application so I can inform my testing. That definitely gives you the good information on that front.
I have a question. I don't know this tool, but the question is, when a test failed, does it tell you exactly why it failed?
It would depend upon, you would have to, certainly the way I scripted it there, no, if the test failed midway, you're not pushing
Yeah,
any data out.
definitely.
You know, you could add an after hook that would run whether it passed or failed and push up whatever data existed.
And it will be shown in the later on the tool.
Yeah.
Ah, okay, got it.
Yeah.
Any other questions? Anyone?
I have a question. What do you have any recommendation on how to decide which metrics? Because you mentioned data lakes are expensive, so we have to be careful about the metrics that we decide to store. Any recommendation on how to choose them?
Carefully. Like I said, at this point, the perf tester in me is going, capture everything, capture everything, capture everything. You know, I would start by, you know, certainly taking a look at, do you have, you know, some of the things that Henrik was mentioning about, you know, adding the tags to your headers. You know, what information do you gain that you can mine out of what your end users are doing, and look for gaps, and then start adding, filling in those gaps.
Okay, first of all, thank you, because this is a topic that I had an argument with my team because they thought that this is a bad practice in some ways. So basically, my question is, how can I actually argue with my team in order to say, okay, no, this is not a bad practice. We can actually do it. And that's it, because I don't know, for me, it was not an easy thing to argue with them because they said, no, that is not possible. Maybe, I don't know, they had their reason, but that's it.
The way I've approached it in the past is adding value, you know, trying to add value. You know, it's been mentioned before, everybody talks about pushing left. Well, you can push right as well. How can you as a tester help the ops people? Giving them more information that might not be as readily visible. You know, giving your teams information, you know, like I said, your customers worry about their workflows. They don't worry about how your application is doing. Oh, gee, my application isn't loading correctly. Well, maybe their servers are, I haven't seen a single person say, well, maybe their servers are backlogged and I just need to wait a little bit. No, they'll jump to something else. You know, bring that perspective in, try to bring that perspective in, and you know, be a champion for it. I know I'm not giving you great advice, but.
No, it's okay. Thank you.
Yep.
Anyone else? Any takers? I don't think so. So, in that case, thank you so much, Andy, for joining us today.
Well, we have some few announcements before the break. Thank you, Andy. First of all, wait a second. Hey, I was talking English. So I just wanted to mention that I really like what is happening, the good vibes, the energy, everything around here. It's amazing. So thank you all for that. We will make a break right now. There was supposed, maybe you can help me with this, but we plan to have a few food trucks outside. There was a last-minute problem, as you know, that things happen. So luckily, there are a couple places around here.
Exactly. So we have 3 options around here. There is a restaurant called Ble in Nahuela Park. We also have a Subway in Aguada Park as well, and there is a store in the one block away from here as well, 360. Las tres opciones son Ble y Subway en Aguada Park, o si no, la tienda del 360 que está en la estación acá a una cuadra.
Todo es a una cuadra de distancia,
Sí,
más o menos. Así que, ¿a qué hora volvemos?
Estamos regresando
2:15.
a las 2
Y cuarto.
sí, cuarto.
2:15 estamos acá entonces. Muchas gracias.
Gracias. Everyone. The next track is called Performance Testing, Measure, and Metrics, and we give a warm welcome to Mark Tomlinson. Welcome, Mark. So Mark is the chief performacologist at PerfBytes, currently working full-time as a performance architect at a startup in Philadelphia. You can follow him and the other PerfByters on YouTube, Twitch, LinkedIn, and Facebook. Just search for PerfBytes. So the floor is yours.
Awesome, thank you. Hello, buenos dias. Are you ready? We're going really fast. All right, raise your hand if you're a performance engineer tester. Perfect. Then you know what okay, this is your life. You give some graphs, pretty pictures, pretty colors. Green is good, red is something failed, right? We have to have these colors and pretty graphs. When we put together metrics and measurements to prove that our work was valuable, it usually ends up in some kind of a graph or visualization. And if you're new to doing performance testing, the real question, how did you get those pretty graphs? Because usually we come up with some kind of a number that just says 42. What's the number? How many users? 42. It's also the answer to the question of everything in the universe, right? So the two little graphs. 42. So hopefully I'm going to for a little bit of metrics and measures. Oh, let's make sure we're good. We're still good. Okay, 42. Metrics and measures. So we'll talk about metrics first, and then we'll talk about how to use the metrics and come up with what would be displayed as a measurement. Myself, I had a lovely introduction, thank you, Paz. I am a full-time performance architect, and I play a special role in a fairly small company, running around doing performance work, infrastructure work. I also do, in my copious amounts of free time, PerfBytes podcasting. I also spend time teaching workshops and doing education, mentoring, but I'm also a guitarist. As a human being, I'm a musician, and my friend Enrique, is also a guitar. You heard the song of the sound of observability, which is great. And we're also members of barbecue and the Paria. So let's get started. I'm going to try to. This is not clicking so well today, so I'm going to have to change this a little bit. The agenda. I'm going to move that to see if that helps. Our agenda today. I want to go through logical measurement metrics. I want to go through physical metrics, ecological metrics, and then some application level metrics to tie all these things together. And then we talk about measurements. So once you know what a metric is, then you can start taking measurements and sampling those metrics. We'll talk about trends and curves. We'll talk about performance correlations and how you would visualize the correlation between two different metrics that are interesting, and go through extrapolation. And extrapolation doesn't necessarily have to be evil, as you may have heard. But it all starts. This is going to bug me. Let's start with metrics. Logical metrics. The number one logical metric, I say it's not physical, but is sort of quasi-physical, is time. And it's the only logical metric because it's really hard to measure it outside of some chronological, the sun moving over the planets. You look at Response time requirements and business requirements and user stories, end user response times measured in seconds, service level response time measured in milliseconds, transaction response time of some seconds or milliseconds or microseconds even, batch job elapsed time measured in hours or maybe even days. We have some batch jobs or reporting jobs that could run for 2 or 3 days, depending on the size. Your service level agreements, contractually, that's the other place you'll see time show up. I need to have an actual legal document that says this response time must be a certain level or less, 1 second or less, 2 seconds or less. And so everything else we measure in performance, it kind of comes back to time. And so we always hold that one, I always hold that one in my head as, you know, something is happening over time. And so I want you to keep that in your brain as we move forward and talk about the next one, which is usage. So, or load, you've heard the phrase workload metrics. So number of connections, number of users, number of active threads, number of hits per second, requests per second. And then of course, over time, you have stuff happening and that becomes concurrency. Another word is simultaneity, which I hate because it's just hard to pronounce. But concurrency, so how many things, volume, happen at the exact same time. So time and volume. So if I do nothing more in running some kind of a performance test or performance analysis, and I know those two things, time and volume, I actually can do some pretty valuable work. But it doesn't peel away the next layer of the onion. Why is something slow? Why can't we do something currently enough? Why can't I support more transactions? Why isn't our concurrency there? And usually, we find a bottleneck in the 4 core physical areas. The physical metrics start with CPU. How many of you have built your own computer? Good for you. It's an amazing way to learn these 4 core things. 1, you have to buy the parts. Number 2, you actually figure out how they fit together and how they work together, and you learn about compatibility. You can't just take any CPU and throw it in any motherboard. They have to match. And so let's talk a little bit about physical performance characteristics for CPU. Come on. There you go. A processor is a central processor. Back in the day, there used to be sometimes only one digital central performance processing unit in a computer, surrounded by a bunch of analog circuits that supported the one digital microprocessor that was in the heart of the computer. And then, of course, as soon as you figured out how to make one of those, then you made 2 of those, then you made 3 of those. And now microprocessors and everything. There's probably a little microprocessor chip here, there's one in your phone, there's one in the screen right here, the audio systems. It's everywhere we look. There are multiple microprocessors. And they run with different architectures, like CISC-based processing has a different architecture than RISC-based processing, different than EPIC or ARM. And they have these things called pipelines. So you can put a set of instructions from a compiler and have them 2 pipelines, a single pipeline or multiple pipelines, go into a single core of a processor. So if I'm a processor and there's a bunch of application code that's come all the way down and I'm going to say, all right, I can do one thing at a time. Well, now I have 2 pipelines. I can do 2 things at a time. Then maybe I can do 6 things at a time. At some point, I just can't do that much as a single processor, so then we had multiple cores. So you go to a quad core, go to 4 core, hexacore. The machine I have on my desk at work is 18 cores. Liquid cooled, really nice. Used to be, it's this big. It's fantastic. It's an amazing little machine, and I get to do lots of stuff with it. When you're measuring, when you're looking at metrics for processor, you're pretty much looking at the total percent. Right? When something hits 100% CPU, 99% CPU, that's the max you can pretty much get out of a processor. If you have 2 applications running at the same time, they sort of compete for who's going to chew up most of that processor. If you have 3 simultaneous things running on a machine, like 3 separate VMs on a VMware box or a hypervisor of some kind, you'll have multiple things competing for a physical processor. And so we expanded the number of cores to do that. An interesting thing inside your application is the difference between system time and user time. So if you are running solitaire, because Roger, I know you enjoy this kind of doing quiet gaming time, playing solitaire, it's a serious part of his day. It's a process that only Roger's user account is running. So solitaire.exe would run in user mode, right? Now, let's say Roger decides he's going to do some browsing, and as he's browsing, he's saving things to the bookmarks, and he's downloading some files that go into the hard drive. He's using the network to get things downloaded, and he's saving some things for work, some documents from a project, to his hard drive. Now he has to talk to system resources like disk and network, and he has to use the processor in order to talk to both of those peripherals. So again, if I'm over here and I'm the CPU, and Roger's doing the browsing, it's like, oh, shit, he's bringing down some networking. Okay, so I got a file, and I got to bounce that around, then he wants to put it in the hard drive, so I got to go over here, put that in the hard drive, and then I come back over here, they get the next document, and then I run and I put it in the hard drive. Fantastic. So that is that takes a lot of work for a little browser processor to do that, right? So what the system does, the operating system says, any of those low-level activities, I'm going to make them high priority. I want to get them done as fast as possible. Plus antivirus applications might be running in the background, kernel mode drivers, anything that needs super fast priority gets system time. One interesting secret for you is if you ever monitor an application that has high exceptions per second, a wonderful metric. Exceptions, if they are system level exceptions logged by .NET or in Java, those exceptions, because it says the word system, they get system time, which means the application, this is some exceptional weird thing. You know what I need to do? I need this exception, take the stack trace, log it somewhere as fast as possible so that the application can keep moving forward. So if you have an application that's unhealthy with a high amount of exceptions per second, you get system time, and everything else goes slow. It's a really interesting anomaly. Obviously, when you hit 100% of your CPU processing, you're done. You're pretty much pegged the CPU, buy more hardware, buy more CPU. And my important note, and you'll see a trend here this week, increased CPU usage creates more heat, right? So if you've ever done something that's CPU intensive in your PC and you hear the fan, if your laptop, the antivirus turns on, the laptop starts going, and the fans, right? You remember that? Terrible. So with 100% CPU usage, you create more heat and use more power and energy. Let's talk about disk, CPU and disk. I just talked about disk from the downloading the reports that Roger was getting. This is as old as I am. This is more of what you guys might see nowadays. An enterprise level SSD, ultra SSDs, super fast SSDs that can go almost fast, in some cases faster than the memory that we might buy for a machine. And the disks are more like long-term storage, but because they're so fast now, they're almost used like an extension of the actual memory on the machine. So we park data there as an object within the computer. I need to log something. It's going to sit in the log for a while until we flush the logs out. I put something in an event log. It's going to hang around locally for a couple of days maybe on the event log. If I'm in a database, very different idea. For a database, you might be building a table and growing an entire huge number of records in a data file on the system itself. So it's long-term storage in terms of hours, days, or even years, and it's measured in available bytes. So what percentage of the disk have you used, right? So moving, I've got a terabyte, I've got 2 terabytes worth of storage, and it's on a very large array, et cetera. You're going to measure the data movement to and from in usually bytes per second. You might see it in smaller amounts, depending on the context, but for the most part, it's number of bytes per second over time. How many bytes read, how many bytes reading and writing and reading and writing. And if you try to read and write at the same time from the same drive, things might get a little bit slow. And it does. In the old days, it got slow because of the spinning platter, and there was only 1 needle or 2 needles or n number of platters. Nowadays, it gets slow because the actual microprocessor on the front end of the drive on the SSD is going to 100% CPU. Now I have a CPU on the disk that goes to 100% when the CPU on the computer goes to 0%, but the drive is waiting. Now you're talking about multiple processors on multiple drives, and things get really confusing. And that means you have latency. Referred to as I/O latency, so input-output requests in milliseconds. With SSDs, you can have a high throughput, a high number of I/O requests, IOPS, I/O requests per second, but those individual requests should be incredibly fast. A big red flag if I ever see any drive, SSD otherwise, going at 10 milliseconds or more on a read or a write, there's something is seriously wrong, especially if it's an SSD. If it's an SSD, that should be tremendously faster per IO request. So consider with disk different roles, applications or databases, if you're logging, running queues, running virtual machines. Those different application roles affect what that disk is do. One way to think about it also is that like CPU is really fast, memory is really fast. Disk used to be the slowest component, and now it's pretty fast. It's a lot like memory. So physical metrics for disk are measured a lot more like an extension of memory. Come on now. And the important note at the bottom, if you push more bytes to and from a disk, if you ever have an external SSD drive or an NVE RAM memory stick drive, an SSD that you can hold on to, if you're recording a video to that drive or copying things to and from it, it'll get hot enough to like you can't hold it in your hand. Platters used to get that way, but yeah, anyway. So creates more heat, uses more energy. More heat, more energy. Physical metrics for memory, very similar to disk, except these are short-term places to park memory. And usually if you turn the machine off, the memory goes empty. A disk is persistent, memory's not. So you have short-term data in physical metrics on memory. And of course, that's more like way faster than disk. In fact, for those of you that have built your machine, if you have frequency in the processor, but you buy slow memory, the CPU has to slow down in order to match the memory. So if you buy an expensive CPU, but cheap memory, you're wasting your money on the CPU. And vice versa. If you get I got really great memory, but I got this kind of slower CPU, you can't use that bus speed. The same thing happens in server computing when they build stuff. You think about Google building white boxes, they have done that spec and figured out exactly the right components to get them to match and operate at the same frequency. It's measured in available bytes. So bytes in use, available bytes, if I have 8 gigabytes of RAM, 20 gigabytes of RAM, 100 gigabytes of RAM in the box, you can see it being consumed. If there's a memory leak, it gets consumed really long. We'll talk about that. And if you usually have some kind of swap file, which is to say there's things that I'm getting some pressure in memory and I don't want to keep it in memory, it's kind of stale, I'll just push this out to the swap file on the disk because I don't need it. So here's the processor, it says, okay, memory's kind of getting full and this thing's really busy, but I have these blocks of memory that I don't really need. Let's put them on disk. And so I take that and I take that memory and I come over here and I put it on the disk, and the minute I put it down, I turn around and the application says, hey, can you give me those blocks? So go grab that, come all the way back from the processor, and I have to put it back in the memory and tell the application, there, it's back in your memory. It's back in memory. So you get these kinds of slow operations that a processor has to juggle in order to get all of this stuff to work correctly. So if you're working in .NET or Java or some of the other object generational languages and runtimes, there's this thing called processor cache. Processor cache has actual memory sitting on the CPU. So if something needs to swap or create objects really, really fast, let's say I create a string in .NET, that string gets created right here on the CPU. Because if you've ever written your code, the minute I create a new object for a string, I bet you like 2 instructions later, I'm going to use that string. So why would I create that string over there in memory? And I could actually have that string new created right there. Now, if the string hangs around for a couple hours, I might promote it into Gen 1, Gen 2. If it's a really big string, I might have to put it into memory. So there's optimization built into .NET or Java for processor cache memory. I have this goopy thing there. The active heap in memory can be fragmented. It's kind of unusual in the hypervisor world, but applications can do all sorts of block swapping and accessing memory in a very random way and growing things so you can have fragmentation. With memory also, once you fill up maximum memory, you get out of memory errors. So you hit 100% memory, you're done. You can't use any more memory. And of course, if you buy faster frequency memory, it creates more heat. Uses more, it's operating at a higher frequency, so it uses more energy to do that, and you have to cool it just like you would the processor. Last one we'll talk about, I've done CPU, we've done disk, we've done memory, let's talk about network. Network is now the slowest physical resource within the computer. It has link speed capacities. Here you've got anything from, you get a 10 meg, 1 gig, 10 gig, 40 gig, 100 gig. Somewhere somebody's probably got terabyte network speeds on a single pipe. We've kind of defeated that purpose with horizontal scaling. We can scale things out. You can do vertical scaling of networks, add multiple network interfaces on the same machine, team them together. And it's measured with percent bandwidth available. So on a single cable, if it's fiber or if it's copper, you can only put so many bytes per second, or bits per second usually, down that wire. So if you have a very chatty application that's moving a lot of traffic back and forth, you look at the percentage bandwidth used. Look at the actual bytes, the actual throughput, and the indication that the network is unhealthy is typically in percent errors, could be packet retries or retransmissions. Something is causing the network to fail. It has to resend. Oh, you didn't get that packet? Oh, you didn't get that packet? Particularly, well, UDP is very tolerant of that, but most of our HTTP, TCP traffic is handshaked such that we need to send your packets, it gets there, it gets back. So if you have to retransmit packets, something is reaching its capacity, and you'll monitor that to see what's airing out. It could even be the CPU on the network switch or a router that's reaching maximum capacity, and it's like, oh, I'm not very good code. Maybe I dropped some packets here and there. It can be a bad cable as well. And once your bandwidth reaches 100%, you are totally maxed out. You're done. Usually about 85%, it starts to throw errors, but definitely you can't use more bandwidth. You can't move more bytes than you actually have. Oh, and guess what? The more network you use, the more energy you use, because each network, your NIC card, the switch, the router, every switch between you and the server, those are all little microprocessors, and the more work they have to do, the more CPU, the more heat they create, the more energy they consume. So if we do more work, it's going to create more heat and use more energy. Now there's a handful of other metrics to talk about, and particularly, hopefully you've got my hint. Come on now. There we go. You're picking up my hints about ecology, heat, memory. I'm going to thank the Abstracta team on Sunday. We were driving around Uruguay, and we were just talking about climate change and talking about heat, and I thought, I give all these great talks about CPU disk and memory and network and optimization, and I keep leaving this stuff out. So I'm adding it in. So ecological metrics that you may not ever be able to measure today, but I'll make it my goal. We should figure out how to measure these things all the time. On my phone, I can see battery usage. I can see battery consumption. On my homemade PC desktop, there's an app I can install to see the temperatures and the fan speeds. But on my enterprise server running my website, there isn't a monitoring inside the application. When I'm running a load test, I'm not monitoring heat. I'm not monitoring T-delta, which is the temperature difference from the front to the back of the machine. There's a coefficient for performance, which is how much energy to cool the BTUs being created. There's some other stuff in HVAC for measuring efficiency of an air conditioner. And of course, large data centers have air conditioners. BTUs are the British thermal units. So they have the BTUs per hour or watts per hour that you would use. The more heat you create, it takes energy to create that heat because you're using it. Then it takes energy to create the cooling to remove the heat. And in the end of the day, you've spent a lot of energy to just create more heat. Yes, you're streaming a Netflix movie and it's very intuitive.
So where you have an instructions to write and the kernel says, oh, I'm going to go to the network. So it's even further than locally. And I think you didn't mention, but I was wondering if it makes sense from your perspective to also figure out about the waiting time, because the CPU, sometimes you're consuming CPU, but the CPU is not actually doing things, it's just waiting.
It's lag, it's CPU lag. And in super microkernel computing, it's your sleep zero. It's latch. I only need to wait a fraction, like a super fraction of a microsecond to just try again to get to something. So latch time can be where that lag comes from. And of course, anytime you go across a wire, that's the speed of light or the speed of an electron can only go so fast. So it's going to add to that lag time for CPU acquisition of resource, right, with latch time. But that infrastructure where that time comes from is changing a bit. The one comment I'll make about cloud computing is we don't start like with the free, woohoo, cloud, let's go. And then you expand a little bit, wow, the costs are getting up there. At some point, somebody says, well, we really need this to go fast. And the cloud vendor says, well, we can give you dedicated systems. And what are your dedicated systems? We'll remove the virtualization. We'll put you on, we'll just go back to good old data center rack space down the street. Oh, yeah, we're going to give you your own Kafka instance running on bare metal. And at some point, and I'm watching this with AWS vendors, I'm watching with our own Azure stuff. Yeah, it's great for kind of these little ephemeral things, but if somebody who says, I really need the power, oftentimes will end up on dedicated provisioned hardware, which is just, that's just outsourcing the whole data center physical stack at that point. They get the convenience of the APIs. They get convenience for automation, but they're still chewing up juice the same way to try to shortcut those lags.
Okay. That was all of our time. Thank you so much, Mark,
You're very
again,
welcome.
for everything.
Muchas gracias.
Perfect. So right now we will change back to Spanish. ¿Ibas a hablar? Okay. En 5 minutitos empezamos con la charla con Roger de JMeter Scripting de Missing Piece.
Or Success Sidekick. Many software companies, from startups to Fortune 500 organizations, have a similar problem to solve: where to focus their efforts. While some companies focus their selling efforts on
Abstracta. Roger es ingeniero de software con más de 17 años de experiencia en desarrollo, enfocado especialmente en desarrollar aplicaciones de alto tráfico y robustez. En su carrera ha pasado por diversos roles como desarrollador.
Roger has had several roles as a developer, for example. Welcome, Roger. Thank you. I need to make some adjustments first. That's better, at least for me. This time I'm going to speak in Spanish. JMeter scripting, the missing piece. Let's start by JMeter, an open source tool. It's for free, based on Java. It's one of the most popular tools for performance management. You have a lot of documents you can access to. It's a very flexible tool that supports protocols, and it's very extensible. You can install plugins. You can have your own. And as it is based on Java, it has the advantage that it has the Java ecosystem support. Some of the other advantages are that the ecosystem has a lot of tools, a lot of companies that build JMeter tools. It is based in GUI that makes it possible for people that are just beginning in this world to start with their scripts without even knowing how to code or coding languages. But even though it's a very popular tool, it has some disadvantages when working with it. This interface that allows to create test plans makes the test plans or the scripts to be slow as compared to other alternatives when creating the script. And the test plan visibility may not be as easy because our test plan may be a tree and we need to go over the tree to discover all the settings, and we have different nodes, different screens to see what we have been changing. But another disadvantage may be when working as a team. When working with GIT, the test plans are filed in different parts, and it's hard to interpret what is being said only by looking at the XML. When we want to see what has changed, we need to know what properties are being used to understand what has been changing. So when working as a team, this may be kind of uncomfortable. We don't have documentation in the same tool. We may need to access a different website and look around the internet. So that may make it hard to discover the functionalities. And it does not have any feature to allow us to see if, for example, a test plan had a determined test plan response time. So maybe you can do it by means of a plugin, but it may not be as effective. Obtain the file, some things, but the others have the other things. So you may need to be changing tools. So all these tools are great, but it would be great to combine both approaches, to have all the functionalities of JMeter, but have the functionalities of these other tools. We developed JMeter SDL, which is a Java library. We'll be starting a demo now. You will learn about functionalities, the benefits, and you may go home with homework today. So let's start with the demo. let's add a new project, a new test plan. This is not what we used to recommend. We recommend teams to include their performance scripts in the same place where you have the code, in the same repository or as close to the production code as possible. This makes it easier to continuously test the app. In this case, I don't have the production code, so I'll make a new test plan. This is a code repository, which is open source. I'll go to sample project. This is another repository that has a very simple project as an example, which shows the dependencies and copies the dependencies that I need. First, we'll create the project. You may use what you wish. So I'll name the project. I copy the dependencies. Most of them are the ones that you use in any other project when you run any test. Specifically in this test, I'll use JUnit. I'll use a Sergey. I'll zoom. Yeah, that's better. I like Sergey, but you may use whatever you like. The only dependency that we'll be including is the JMeter DTL library. With this dependency, you won't need JMeter or set anything else. With this, you will be able to do and execute your performance script. When you execute, you automatically had an embedded JMeter. I'll name Dynamic Test. Now we're going to create a test plan, which is the basic concept in JMeter. The system is saying that something is missing. Now the dependency is included, as you can see. This class is the one that is included in all the methods that you may use. With this way, you don't have to import everything at that same time. Now I'm going to create a thread group to define the load profile, the amount of virtual users, as you may have listened in the other sessions, how many threads I'm going to use in the tests, and for how many, the duration of the test. We need to include the steps of the thread. We're going to create a thread group. So this is the first advantage of using SDL as compared to JMeter only. We see that this is very fast to find things, whatever I wish to include, and also to find related things. We already have the help we need to make the scripting faster. This is how we start the test plan from scratch to begin our test. If I choose I have the options that I may wish to use. So this makes the process faster to find the elements. Another advantage is that I also have the required attributes, because we may have in another alternative, we may have a lot of fields and we may not know which one to choose. So in this case, this is faster and is one of the best practices. This is, for example, just a gaming app. If I wanted to post, I have the options now. You have the possible settings with the sampler. We are now writing the body and the content type. This is one of the typical issues in JMeter. I want to use a post. I send it, and it may start failing because you may have forgotten to include the type, the content type. So this is one of the best practices to avoid common mistakes that JMeter has. So what DCL does is to make it easier for JMeter users. I still have red, so I still have something missing. These are the things that I can do with the test plan. I start running. You may use mating if you wish. This is a JUnit test, which is integrated with the tools supported by JUnit. You may use the continuous integration server that you wish to use, and to have the reports that the servers provide. So we can see that our request is run. We may add something to see the requests and the responses. We may add a visualizer. To identify or review if what we're doing is what we want to do in fact. If this is my expected results. We can see a new window here, the request body, the headers, the header response. When you're testing the test plan, this is what you see. So after you finish, you may erase it. If you run this in a continuous iteration, you remove it. This may be very intuitive, and which may not be the case in JMeter. So in this area, this may be more natural to remove something that we don't want to have in another environment. So we now know that the test is working. We now want to see how the service is, the behavior of the service, to identify the thresholds that I wish to set for my test when I want my test to fail or to be successful. So let's add a load. Now we're going to use an additional module, the dashboard. That is not something that is used all the time. It's a separate dependency. So dashboard it is. Dashboard visualizer. I now have the import. Now I run it. This is a custom component that JMeter does not have. that allows us to see as we are running a test without having to depend on an external dependency to see the results of the service in real time and have an idea of the performance of a service as a test is running. This is a GUI. It's not, it doesn't make any sense to use it in continuous integration. Maybe we can use another alternative, but we do have another alternatives that may allow us to save these reports, maybe by using Grafana. I have a screenshot that I can show. This documentation shows an introduction to JMeter DCL and our concepts, including best practices and maybe some warnings of some uses of some components. What we try to introduce a step-by-step use of JMeter DCL. The elements may have maybe including the user guide, but this may not be necessary because if you push Control J, you can see the information and descriptions of the functions. So this avoids for us to have to go to visit another website while we are scripting. So it's easier to understand what I am using. Now I'm going to show you Grafana. This report is made with Grafana in the user vault. We have an example. You have to run this, run the test, and you'll have the statistics in real time of how the test is going, and you may check the browser history. And with the history, you may make comparisons and reviews. We were talking about statistics. We can visualize response times, transaction numbers, threats amounts, and the average, which is half a second. I'm not going to use that, but you may do in your tests is to make it fail or to make it successful based on a specific condition. For that, I'm going to save this test plan. We have variables and results. And with this statistics, we can do assertions. You can use stats. We have different statistics. We may use overall, which means global statistics or label. If you wish to see specific statistics, for example, I can now see the sample time that is used when we wish to evaluate and assess the performance of an app. Now I'm going to check if the response time is below 5 seconds. So I need to find direct duration seconds. Sorry that I'm speaking in Spanish as I talk, in English as I talk. If the percentile 99 of the response time is over 5 seconds after the test, this test is going to fail. And it's going to be failed in JUnit. Yeah. This is a performance test that may run in a continuous integration server, I may include an acceptance criteria. I may have another criteria based on errors. So this coding may be scary for some people at first, but you have some functions that make it friendly. If you're not very familiar with coding, you may also have documentation available. Another functionality is, this is, for example, the last step when obtain testing performance. You may see load that is limited to the running hardware. For example, you may generate the load that the hardware may generate and what the server can handle. So we may want to use a machine cluster to generate enough load to generate the load that I want to. So for that reason, we included four engines. One is the one that I'm using, the embedded engine, which allows you to run it right here. So another engine may be used remotely. You may use run in and choose the engine that I want to use. For example, distributed JMeter engine that you want. You can define the hosts, and you can use the JMeter functionality of working remotely in different engines. And the benefits are that you can define the functions yourselves, but which can be complicated at the same time. Another approach, another one of these engines that is a paid functionality, which is worth it. So don't be scary. Don't be scared. If you add this dependency, for example, like I'm doing here, I'm going to obtain the token, the authentication token that I need. And with that, you have the running test in a cluster of machines that you may set yourselves. You may be able to set different aspects of the executions in JMeter itself. It's very easy to escalate. So this is a very good performance test, which can be very useful. The last functionality that I want to mention is, for example, I have JMX files. How should I start using JMeter SDL? We have JMX DSL, and you use it as an input, and you'll be able to have a DCL code. This is not only useful to migrate or to start understanding the program, but it's also useful in the sense that you can benefit from the ecosystem that you have already tried. For example, you can record with an extension of the recorder. You generate the GMX, generate DSL, and start working with the DSL. Another benefit may be that it's very easy to do the test in modules. If I want to leave the test in a certain place, I can use a specific method, my sampler, for example. I have the option to replace it. And this is structured in a method. If I want to use a parameter, I can use this as a variable. Here I can add users, for example. So it's easier to modularize and use the certain modules or parameters and navigate through my test plan. I have 4 minutes left. So I'm going to make a small summary of the benefits of the tool. It has all the JMeter benefits of the Java code and some additional benefits, some like the features that I had mentioned recently. Please go to the user guide. You have a channel here. We want to make this to make a shared tool. So if you have any questions, please do ask. Any questions? Does anybody have any questions? Don't be shy. My question was if it can be used the library without JMeter. I didn't understand that part very well. I mentioned it at the beginning. You don't need to have JMeter installed. Our program has all the JMeter dependencies, and when it's running JMeter locally. That is connected to the other JMeters and executes the tests and collects all the information and centralizes it in the same place. You don't need to install JMeter. My question is, what JMeter versions are supported? Is it all of them? JMeter includes the last version. JMeter DCL includes the JMeter latest version. Some users asked about this because they wanted to migrate to the last version because they didn't have it already. But we tried to use the latest version of JMeter. If you have any doubts about it, you may create an issue at the repository. This is because sometimes JMeter only runs in version number 4. So that was why I was asking you about this. You may have some issues with the conversion of GMX to DSL. We are continuously trying to improve this all the time. So if you see with any specific version of JMeter that it's not supported, or if the conversion is not successful, just raise an issue in the repository in DSL, and that will be helping us to help you. Any other questions? I think your work is great. This is classic Abstracta. My question is, what about plugins? You have a lot of scripts that you can use plugins. How are you working with this? This is a good question. when I showed the thread groups. Just to make it short, some of the JMeter plugins are included in SDL, sorry. We created a module. As people ask for different functionalities, for example, a new plugin, we add a layer and add an app in the library that allows you to use the plugin easily. If you see that there's mainframe missing, you may create an issue at the repository to help us. Thank you. We have a 5-minute break now, and we'll be having Almudena Vivanco next. Thank you.
Markets, creating sticky customers, focusing on your strengths, and lowering investment and risk. Blaze Runner makes it easy for our partners to keep excelling at selling to the big boys while gaining smaller-sized customers to grow and increase brand awareness. Let's talk about how Blaze Runner can be your success sidekick. Visit us at blazerunner.io. Your success sidekick. Many software companies, from startups to Fortune 500 organizations, have a similar problem to solve: where to focus their efforts. While some companies focus their selling efforts on smaller companies, others drive forward with landing large deals right out the gate. The latter usually means a couple of things. The customer base is considered enterprise companies. The customer has large teams. They have larger budgets to spend on innovation and growth. They are concerned about delivering their own products faster and more cost-effective. They are stickier customers, and they grow faster. Focusing on these larger customers means that there's typically a longer sales cycle. Customers require specific things that help drive innovation in your product. There are highly customized pricing models based solely on the customer. All of this is great and should be going on. But are there missed opportunities by only focusing on large enterprise clients? Yep. There are many small companies that will grow and fall into the category of what you consider to be an enterprise customer. But by not focusing on these customers, they may end up on a different solution and will stick with your competitor as they grow. That's where we come in. Blaze Runner is an organization that was born and raised in the land and expand model of selling and has seen it succeed time and time again, seamlessly partnering with billion-dollar companies to drive growth. We focus on bringing our expertise and solutions to help customers who do not want to lose focus of their current successful efforts, but would like to have supplemental revenue while the big deals take longer to close. At Blaze Runner, we focus on holistic sales and marketing, e-commerce, accessing untapped markets, creating sticky customers, focusing on your strengths, and lowering investment and risk. Blaze Runner makes it easy for our partners to keep excelling at selling to the big boys while gaining smaller-sized customers to grow and increase brand awareness. Let's talk about how Blaze Runner can be your success sidekick. Visit us at blazerunner.io.
process. Almudena is from Spain, Asturias. She's been working in performance testing for over 20 years. Welcome, Almudena. A personal detail, I want to say hello to my mother that is in the hospital right now. She's watching me via YouTube. Uh, I have always been the performance girl. Now I'm going to talk about the chaos. I used to do negative performance testing. And the first thing I learned is that chaos is not to break things. It's to prevent them from breaking. To prevent and to know how they're going to break. So if you have a functional environment, we work traditionally, and it came a time when we started using the cloud. We are now globalized. We do not provide service to a country only. We provide services to many countries in many languages. So the traditional approach was not enough. And then COVID came. If maybe you were about to release something, but then COVID, bam. The thing is, then I'll continue talking about COVID. Knowledge used to be in the hands of one person only. Oh, I don't know about this, but maybe it's one person only that knows about this. He is working on this project. He may know what is going wrong. And then we started working in microservices. So we need more superheroes. Now, there wasn't only one Superman. We have many Superman. So if we have a lot of microservices, we have lots of Superman. So we now have the Justice League of superheroes. But we may have a lot of microservices that we cannot fulfill. So we need to provide them with superpowers to make them work. We may face problems, avalanches, because one microservice might not be working, and we may not be as strong in the face of a problem. We may even create a service that we don't even control. For example, I may be a bank and my payment system is not working. So we have single point of failures. They may be a human mistake because microservices are rather complex. And the problem may also be human or software related. The biggest system failures were like the Amazon or Facebook. All of them were caused by problems in configuration, or except one of them that was caused by a shark. Let's call it a shark. So most of them are caused to one person only. For example, if someone removed systems in the configuration without realizing that the load was rather high and millions of users were there at the moment, and everybody was stuck and everything fell like a waterfall. For example, monitoring may be green, but all of a sudden everything may be shut down. So we need to learn from these experiences. What we need to do is to learn from our mistakes. And this is how we create the villains. That may cause complexities, uncertainty. We may continuously fight these villains like circuit breakers, and that we may need to fight and mitigate. For example, cancellation dogs. But chaos sometimes may be caused by just us and us only. For example, due to configuration changes. So we are our own villains. We are the ones breaking the code. We turn into the Suicide Squad. We become anti-heroes. And we need to learn what the villains do. And to fight a villain, we need to think as a villain. What's the difference between the superhero that does performance and the villain? The difference is that the performance wants to learn about the limits and the boundaries and extend the performance vision, because you are not looking only at performance. You want to make the system resilient and error-proof. So we try to create an order within the chaos. We want to know what is going to happen within the chaotic context of COVID. We may encounter an anomaly or unexpected load. So we want to find the failures and the problems and become superheroes. So we to allow us to find the problem before it strikes. So if I know that it's an anomaly, I know that there's a storm coming. So we introduce chaotic events in a controlled way. We are working in performance. We are in the environment that we want to. Production statements, staging, local. You may introduce chaos in a controlled way in the production stage. The other thing that you can do is, while you are performance testing, you can monitoring in real time these events to simulate what will be happening in reality, and to advance the different problems that may arise. You may check the metrics during the testing phase, the loading testing phase. You are, for example, doing stress testing, endurance testing, and you try to understand where the system may start breaking, and try to understand how the problems may be starting, what is happening to the system, what metric you can have to detect the anomaly that may end in an error. So you need to measure the impact. How did chaos start? That was a big explosion, and then dinosaurs appeared. Netflix that was already transitioning to a cloud. Introduce the revolution of understanding a new type of performance testing by injecting failures to the infrastructure. What may happen? For example, failures in hardware, in the switch, in the database access, many kinds of mistakes. These are not the public cloud providers. They defined the system under test, defined the normal behavior, and the starting hypothesis. So this is my scenario, my loading scenario in production. And then designed some kind of experiment for chaos testing. So they executed the experiment in the, like, making it fail for the database, and then analyzed the data, validating the hypothesis, and re-executing them. The hypothesis validation was to collect the data of production and bring them to the test environment and do it again, this time validating the hypothesis. So the superheroes of the Justice League get together and talk, discuss, create a theory, and draw benefits of the testing. Because if I don't draw any benefits from the test, why should I do the test? So the first thing is to build a hypothesis. I have an initial state. I want to get to a final state of stability, but in that period, I have some errors. I have insecurity. I create transition behavior because I'm going to create chaos. So I have the regular state, the regular state, and then you get to see what the impact was after you have introduced an anomaly. There are different things to take into account. We have small chaos that are easy to recover from. They are the most typical ones, but are the easiest ones. So there's not much to worry about. Then we have those that produce an availability problem. For example, you may have an outage in a microservice that I'm dealing with. So what happens in this case? What happens with this lack of availability? There's problems in your side, but it does not create a full outage because the system will be able to recover. And then you have those that are big and critical failures that are on your side. High chaos, for example, are the ones that have had a produced a big mistake, a big error, which may be easy to find, but not so easy to recover from, because you need to have version compatibilities. So you may not find it as easy to make a rollback. And then you have the stream chaos case with errors that are very big, but are not on your side. For example, a flood, things that are beyond your control. So what happens in the real world? If I say, oh, I'm using the cloud, so there's no problems. Everything is in the cloud. You may have some dude in Iowa in a data center. So you may be at ease because someone is behind there after like watching the cloud, but you may have to consider hardware failures. Then you have code errors. Our developers may cause software failures. We have events that are not of error, but provoked anomalies. For example, an anecdote. A friend typed instead of 1,000, he typed 1,000,000. So he didn't realize that when after making that mistake, he wasn't able to turn it back. And he had to recreate the whole infrastructure again. So that wasn't easy to recover from. So you need to take into account the dimension of the CPUs when configuring, among other things. Please raise your hands. How many of you have found configurations of your software that have come set from scratch? We are our own anti-heroes. For example, I may see myself as the great aunt that knows everything about a product, but chaos may come, and then this may not be the case at all. So villains are the anti-heroes. So we need a Superman. So we need help to achieve automation. At the beginning, nobody knew anything about microservices. So what we need is automation to keep things alive and constant through time. We need to treat complexities in a way that you analyze a problem part by part, and then you analyze a whole picture. This can be done in every layer, in every microservice, hardware, CPUs, disk. the metrics that we have are the same metrics that are in the cloud. You may have unlimited access if you have an unlimited credit card. So we may need someone that can see beyond what we have found. Because we may not be prepared. So be ready for expect the unexpected, so to say. So roll back, roll back. So this is why automation may be helpful. You may roll back easily. Discover the unknown. For example, if I just for me, software is something that responds. And what happens if it does not respond? If the software does not respond, what am I to do? Sometimes this may be beyond my scope. For example, if I'm always experiencing a timeout, I need to discover what is going on, but this may be beyond my reach. When you introduce chaos, you need to reduce the downtime. You are exposed to the production errors and you are trained to be able to recover. This is not called the performance environment, but it is called training environment, which you face exposure to chaos environment. And where you constantly see pod failure. So, and to check if the red flag system has worked. So you get the training to be able to recover the system. The best practices to test is to have an action ratio, an action scope that is small. So don't run a test that outages the whole server from scratch. For example, great chaos, high chaos. The ones that are the most common are the low ones. So the action radius needs to be short. The tool, choose the one that is better suited for your test. If I need to introduce failure in an infrastructure, I may choose Gremlin, for example. If you have a chaos scenario, you may choose the one that is better suited. First, practice, introduce failures in a controlled environment. Remember that you'll be taking them to the production state at some point. Production needs to break. If you don't break it, you need to wait for someone to break it. Please measure the main time to recover. Train your teams to recover the system and to have it 100% available. Because if it breaks, they would take less to recover it if they're trained. and may take it to another region. Please be trained because we are always subject to failure. Men fail. Humans fail. So we need to have rollback at our disposal to be able to get to the production environments. Because if something happens, users may not realize because you may have the tools to recover. Most tools are open source, Litmus, and Gremlin. Depending on your needs, the one you will choose. In this case, I'm using Chaosnet because I'm using the preview version of this tool. The infrastructure is in Azure, which allows me to have a central dashboard to control Kubernetes and clusters and the chaos experiments. And I control all of it. I may do something else. For example, injecting another tool to the Kubernetes, but I wouldn't have everything centralized. Why am I using the one that I'm using if you can use whatever? The important thing is observability. You need the full vision. So this tool needs to centralize your system of experiments. So this is why I choose the tool that I'm using. So I'm running out of time. So this is the code. And you will be able to see it if Fede invites me to deliver the workshop. Thank you. Thank you, Almudena. Now we're going to take a break for half an hour. We'll be coming back at 4:35. Please visit our sponsored stands in the ground floor. There's coffee and beverages. See you.
The #1 software development tool used by Agile teams. With X-Ray, close the gap between your testing and development teams. Deliver high-quality software, better and faster than ever, with total confidence. X-Ray allows you to create, organize, and execute tests. Plan your testing strategy. Integrate with leading automation frameworks. Integrate with CI/CD platforms. Report and ensure all of the features are tested. Creating tests is easy with X-Ray's intuitive user interface. X-Ray relates your requirements in Jira with test cases and provides test coverage visibility over your projects. With X-Ray, you can execute manual tests right from Jira, import automated executions, and write BDD specifications with Gherkin. X-Ray's full REST API gives you unmatched integration possibilities. Our native support for CI/CD tools and test automation frameworks empowers your teams to find and fix problems sooner. As your testing efforts scale, X-Ray scales with you. Organize your tests into a hierarchy of folders to improve execution and visibility of results. Once you define your test strategy and scope, create a test plan to track the status of your executions, requirements, and overall readiness to deploy. Requirements traceability, visibility, and well-defined KPIs take your reports and dashboards to the next level. X-Ray's reports and gadgets empower you with live data so you can make smart decisions. Our mobile app lets you take X-Ray's insights everywhere you go. Never deliver broken or untested code again. More than 4.5 million testers, developers, and QA managers trust X-Ray. See why over 5,000 companies consider X-Ray a mission-critical tool. Check for yourself. Start your free trial.
Let's keep going, everyone. Next talk is called The Twists of Performance Testing. Details that are no longer done like before. Welcome, Leandro, also known as Señor Performo. He's comes from Mexico, more than 10 years of experience in performance testing and 20 in the tech area. Welcome. The stage is yours. As you can see, we're going to talk about the twists performance testing is having. Who here was in the performance panel? If you've been here for the panel, in this talk I'm going to expand a bit on those topics. I'm going to give you some examples and we're going to repeat some examples. So my varied Mexican examples. For those who don't know me, I'm Leandro Melendres, also known as Señor Performo, a devil evangelist. We advocate for performance. It all started with a blog of Señor Performo on a YouTube channel. There was one in Spanish, one in English, and Señor Performo, ENG for English, ESP for Spanish. I try to publish the content in both languages, so I try to make sure that everyone that wants to learn about performance and IT can do it. I also host Perf Bites in Spanish and co-host of Perf Bites in English with Henrik. We participate in English as well, and with Mark as well. And I finally got my book edited, The Hitchhiking Guide to Projects. And I try to explain there how we did traditional testing. Enough about myself. I want to thank you. I want to thank Abstracta and Quality Sense that allow me to come here and have some asado. So who's not from here? Have you liked asado? Was it too much? I know that it can be too much meat. Thank you to everyone that's here. Thank you for coming to listen to my dumb rant. The menu today, the dumb things I'm going to say, I'm going to compare similarly to what I was saying in the panel on what was the past and what's the present of performance testing. We'll keep talking about new practices in the performance world. So to start, we need to define what's performance. Those who don't know me, I have something that eats me up. There's a misunderstanding on what performance is. But if we do a dictionary deficient testing, it's to know the state of something, and performance means knowing the components, how quick software is. We can do testing and performance of other things, but today we're focusing on software. How fast our software reacts to certain events. These events can be very different. Not only clicks, can be when we turn on our computers, how long it takes to start up, how long it takes to shut down. Response time, that's performance. All these things. It's not only actions and clicks. Efficiency is also an element we'll check with performance testing. That also takes advantage of resources. A click can eat up all RAM, and what happens to our computer? It won't be able to perform properly. It will be inefficient. We want to measure how well it uses resources. The last component is a scenario. Be a single user. It could be just by turning off, on and off a container, the pod, or whatever we're using. So something I want to talk about, that performance is not load. The triforce of performance, like I said, the speed or velocity, we have impact or efficiency. Every situation that happens in our system, what impact will it have in our hardware? And the scenario as well. It could be one single user, it could be without users, it could be a lot of users. Here we have a dog, a Chihuahua dog, saying not all performance is load. There's a lot of variations. Performance does not mean load only. You're going to leave a big gap if you only do this. There's going to be a lot of elements that are not tested if you do this. Well, stopping my rant, there's changes that I mentioned. Why? What is it that is generating this need to change? Well, we've had some evolution. For example, from a traditional piñata, we go to a bit piñata. We have agile methodologies with CIs and CDs. It was different from olden times where we had waterfall processes, where we tested at the end of the process. So another change we have is the cloud. Everyone is sending their software to the cloud. This cloud is not at one place. It's extended everywhere. Sometimes we don't even know where it is. We know it's at a data center somewhere in Brazil, or there's some here in Argentina. They're everywhere. They always end up in the States, generally. So they're distributed. A single software could have a lot of components in various places in the cloud. It's not like before. The way in which we develop software has evolved to microservices, and it allows us to scatter things everywhere. The content is in a navigator, in a fridge, and it can communicate to the backend, and that backend through microservices could be gutted everywhere. Sometimes we don't even know where it is. We know how they're connected, but we don't know where they are. And because of this, we need to change. We need to go through the threshold of performance testing in this new evolution we're having. So these are some of the differences. It shows how they did things in the past in black and white 10 years ago. Now we do things in 4K or 8K. First, performance before had goals of doing that before you released the software. We had a month, 6 weeks, but in theory, but in reality, we had only 5 days. It was an obsession with load. Let's really hit it. Let's use a lot of virtual users. Make the system suffer. Let's make it crash. Sometimes it was not realistic. I had tests where it wasn't really necessary. Talking with Matias of Abstracta, he says that he knows that it shouldn't be done like that, but it's fun. So sure, it's fun, but it's a bit of Stockholm syndrome. What do we have to do? We need to have a continuous approach. Modern goals are not just hitting the system, but just make sure that in each sprint has to be released to production. Each sprint we need to make sure has a good response time. Make our apps snappy and quick, always and everywhere. What do I mean with this? We're always checking performance. We always need to check performance. There is not a second that goes by where we don't know what is going on with performance. We have to know it every time, not just when we're running scripts. In pre-production, in staging, production, post-production. So in all environments, we have to be mindful of this. And in small iterations as well, we need to add things. We need to add little things at a time. We need to see how things that we add affects the system. And these small things, we're going to be measuring them. It's not like before where we just loaded a macro load. You don't need to do that. We just need to go piece by piece. That's a big difference we're having today. I mentioned this before. The obsession with performance was just, before release, at that moment, we did the big load test and just hoped that it wasn't going to fail. We didn't plan for a mistake or everything. If we had to go back, the situation could get ugly. The macro releases that we did once or twice a year was wild. I remember one time we released 3 times, and that was very wild. And we were waiting for the development to finish. And we never even saw developers. We got an end product, and we had to figure out how to automate this. And it was a big problem to send it back because we had to repack it. The developers had left, they had gone back to their countries, so it was difficult to send it back down the line to make them fix it. All we wanted to do was just load, hitting the system. So like I was saying, now we're being early all the time to the project, the sprint or the office, because we have mini releases that we're doing at least by sprint and several times a sprint as well. And maybe once a month we send to production. So we're checking performance all the time in each of the steps. And it goes hand in hand with development. I'm calling it getting up early because we need to be really early, even before the project even begins. Need to work with infrastructure, topology. That input that we have previously is a big difference, makes a big difference in preparing our software. Load tests are not macro loads now. The big ass load test that someone mentioned before. I don't know how to say this in Spanish. We don't say it like that in Spanish. Big tests are not as important now because we are in production, we know it's good, so we're adding small bits at a time. And this applies for everything in general. Some people get obsessed with complete cycles and regressions and automatizations, but it's not necessary. You just need to see what is affecting that small piece you're putting in. Another detail that we were obsessed with back in the day, and it was the first thing we thought about when we talked about performance testing, was scripting. We had 4 or 5 weeks for a project. 60% of the time was dedicated to scripting, of doing reverse engineering of the software to see how we could test software that was already packaged, how we were going to correlate the data that by doing these automatizations and these packaged solutions, we got obsessed with the front end. We saw correlations, we recorded steps. We don't do that today. We had test cases in which the first step was homepage, second login, 3 menu, 4 we'll go to the next menu, 5 was text, 6 what I was really interested in, for example send mail or due process. All those steps were necessary to get to that point. And we had to build complex scripts. That's why it took us so long to do these automatizations, because there was no way of getting where we wanted to go without going through the steps. But we're not there now. Now the performance engineer can go direct, can be arrive to the equipment directly. Almudena talked about having her minions, performance people. I call them performance champs or supreme performers that are going to share knowledge with the teams and helping the teams. That the scripting is not the bottleneck of automation, but they taught people to just do an automation of that step. Now that we have microservices, let's focus on that step and not automatize all the steps. If there's a change in previous steps, the automatization will get broken. And so now we go to our team and we say, this is performance. You can do it this way. Here are the tools. Choose the one you want that works best for you. And make sure that results. Before we were a bottleneck, now everyone can access information, can access and interpret scripts and performance and how to integrate them. And having the whole team on board and in caring about performance. Talking about metrics, these solutions, these monolithic solutions were like black boxes, which we had to gut and see with scripts what was going on inside. Today we have observability. That's a huge step in performance because we can see what's inside the patient without opening it up. This is a drastic change. What I was saying before, my reports, my precious, we were the bottleneck before because we were the only ones who could touch scripts, because we were the only ones who could touch the automation tools. We were the only ones who could execute, deliver, and give results. Because of job safety and all of that, it's not good to do it like that. So what do we do now? Instead of being the only person that could touch this, instead of being a soloist, we're like mariachis that always are switching between the instruments they're playing. Some people can sing and then they can play the guitar, but they're playing music together. Because if not, we become a bottleneck. It's very important. These is all a mindset change. And I really don't have enough time to tell you everything. There's a very wide mentality to performance. I'm just asking you to change your perspective and opening up. I've heard a scandalized tone when people are told that they can use any tool. They get surprised. Don't choose just one tool for everything. Well, I don't want to eat up too much time. I just want to know if anyone has any questions or comments. If for any reason we don't have enough time and we can't answer, you can look me up at SRPERF or Leandro Melendez. I have Twitter, I have Instagram. I don't have TikTok yet, but well, thank you for you to have listened to my rant. Any questions? We have a few minutes to answer some questions. Anyone that wants to break the ice? Is no one scandalized by what I was saying? Thank you, Leandro, for your talk. It was excellent. I wanted to ask if you've been involved in working with these monkey strategies to try the resilience of equipment, and how hard was it to involve teams in this? Are you talking about Chaos Monkey? No, I haven't worked in a project that has implemented this. I've studied on the subject, I've read about it. We're working with similar products that vary the response in chaos engineering, the blast radius. Not just to see the server randomly to see what happens. I've worked with people that install this in your infrastructure and manipulate what is going to happen. And I'll let you know how this goes. Thank you. I have something here for people that ask questions. I have some hats. Any other questions? Great talk. Do you think that this change of mindset could be applied in a high maturity state or at a premature maturity state? Well, I take it as the old dog, new tricks synonym. Yes. I'm going to answer with a joke. How many psychologists do you need to change a light bulb? You do it with one. It's just a matter of the bulb wanting to change. So you changing the paradigm is easy if everyone is on board. But we have our tricks learned, and it's difficult to let them go. And sometimes we have Stockholm syndrome. I know it's old, I know it's not the best, but I want this because it's what I know. Any other questions? My question doesn't have to do with the technical part, but what's the roadmap you recommend for a functional tester that wants to do a performance path? That's a good question. They asked about this in the performance panel. The first step is for you to understand the performance components that you have to pay attention to. For example, seeing response time and just manually and starting reporting it. Sometimes, have you ever reported a slow process from functional testing? So good. It's just for taking the first steps. Go to developer tools. You can see how much time a component is taking up and other details. The first step is automatization for the most part. I would suggest don't focus too much on this, but it is useful. I think that for modern performance, something that can be good for you is to start learning monitoring. You open a dashboard and you start seeing what things are slow, what things are being triggered a lot, and that will open up your perspective, and you can start reporting this to your team if you see something that's slow or gets stuck. It's like a Christmas tree that lights up with mistakes, with bugs, and when you see it, you'll see that it's very transparent. Because sometimes people make it seem as it's only for geniuses, but you can start small in analyzing these kinds of signals. It's like a rabbit hole. Once you advance, one topic will open up another topic, and you'll start opening up your tree of knowledge, and with time, I know a lot of performance engineers that have not studied systems. Mark is a communication guy, so it can be done. It's a really nice career path, helps us across borders. And we've broken a lot of barriers. And there's good money as well in it. Thank you very much, Leandro. I think that's about it. We don't have much time, so thank you very much. I hope you liked it. Thank you. In 5 minutes, we'll come back with Paul Holland's keynote. Where are we heading? We'll see you later.
Paul. Paul has over 27 years of experience in software testing. He is Canadian, living in Florida, and is currently the head of testing at Saks of Fifth. He is one of 5 instructors of the Rapid Software Testing course. So, welcome, Paul. The floor is all yours.
Is this on? Can you hear me? All right. So, Fede asked me to give a talk, and I gave him a few choices, and he selected this topic. So, if it's good, it's all me, and if it's bad, it's Fede's fault. So, I was just introduced, but I've been doing this for a very long time. I am one of the 5 instructors of the Rapid Software Testing course that was created by James Bach and Michael Bolton. My current role is head of testing, although my official role in the HR system is senior test automation architect, because they don't have a role called head of testing. And I can't be a director or a VP because I have no direct reports, so it's bizarre. And I used to be in the Canadian military, and I flew Sea-King helicopters for a few years. So, but that was a long time ago, over 28 years ago. So, weird, it didn't show up here. So, to answer the question, where are we heading, I feel we need to look back at where we've been. So, one of the things that's bothered me a lot about being a software tester right from the very beginning is that software testers are told how to do their job by people who are not software testers and don't know about software testing. So we are told to use certain tools, we're told to write out detailed test scripts, we're told to do all these types of things that are not helpful in good software testing. And it's typically by senior people, C-level executives, chief financial officers who have purchased a tool, or other executives that are, don't know testing, but they've heard that it's the right thing to do, so they tell us to do it. But they don't tell the product owners how to do product ownership. They don't tell the developers how to write their code, although they might have them jump through some hoops, like unit testing and things like that. But for some reason, everybody thinks that they can tell software testers how to do their job. So I tried to figure out why. And maybe it's because we haven't historically done a good job of showing how we provide value by doing it not in the way that we're being told. Although, if you're joining a company that already has these ways in place, it's hard to provide value. So maybe it's also because software testing looks easy. Have your friends who aren't software testers ever found a bug and they come to you and they say, look, I'm using this app, is this a bug? And you go, yeah, that's a bug. Oh, yeah. So they think they can be a software tester. But just because there's so many bugs all over the place in all the software we use now, doesn't mean that it's easy to find the important bugs. And I'm old, and I remember a long time ago when I first started, I used to be surprised if I found a big bug in software that I used. Now I'm surprised if I don't find any bugs in a software that I'm just using. And I don't look for bugs. Bugs, they're just there all the time. So software testing looks easy, and especially recently with how crappy software testing is getting, software itself is getting. Maybe we get told how to do our job because testing has just been done poorly in the past. And this is especially since the ISTQB has certified people. You get a certification to test poorly. The ISTQB historically has told people how to test badly, and then you get a certification for it that companies demand you have, and then they want you to test that way. So why does the ISTQB do that? It's way, and then it cuts out and it comes back. It's happened all day. It's way easier to have to teach people how to test poorly because it's a rote way of doing it. Follow these obvious steps and then answer this 40-question multiple choice test, and now you're certified. Anyway. And outsourcing companies, a long time ago when I first started in the 90s, they commoditized the profession of software testing. They intentionally made it so that they could resell software testing in chunks the way ISTQB has you do it, because it's much easier than doing good software testing. So, I'm now going to go through some historic bad, they're all bad, trends in software testing. Many of these come from the ISTQB, which is wonderful, my favorite organization. So one of the things that many of us learned was write out your detailed test cases, write out your scripts in a way that is easy to read, easy to follow, and has all of the steps there with the expected results. Now, I know this is happening a little bit less now than it was, but remember, this is a historic trend. And this was rampant in the late 90s and early 2000s. So what were the pros of writing out detailed test cases? Well, theoretically, it allows anyone to execute the test. That is way smaller than I wanted it to be, sorry. It theoretically allows anyone to execute the tests. It shows your stakeholders exactly what was tested. It allows for the tracking of the tests in regulated industries. And it shows a methodical approach and thoroughness. Okay? So what are the cons? Well, it's really slow. It's ineffective. It actually doesn't allow anybody to execute tests. So we're going to take that one away from the pros. And I'll explain that one a little bit. When I was working in telecom, around the year 2000, maybe 2005, in that range, I was talking with a senior director at Nortel, which was a Canadian telecommunications company. They made lots of the switches that your offices would have had down here, phone switches and backbone switches. And the lady who was the senior director in charge of system testing had a team, a fairly large team, 20 or so testers, people, humans, who had to execute scripts, sadly, and when they found a bug, if it was found while they were executing a script, they ticked the box in JIRA equivalent at the time that said it was found running a script. And they had, in 1 year, 1,280 bugs that were found executing scripts. And this lady, she didn't believe that the scripts had found that many bugs. So she had somebody on her team go through all 1,280 bugs and see if they were found by the script. So the script said, do A, look for B, and B didn't happen. Script found the bug. Or found by a diligent tester. Do A, look for B, and hey, C, that's not supposed to happen. Script didn't find the bug. A diligent tester found the bug by being observant and knowing what they were doing. Knowing the switch, knowing the product. Not anybody, but somebody who knew the product, who knew what they were doing. And she found that 80% of the bugs were not found by the scripts, but were found by a diligent tester. So if you had anyone execute the tests, they wouldn't have had 1,200 defects found. They would have had substantially less, probably just a few hundred. So anyone can't execute the scripts, even if they're detailed. So it also doesn't show stakeholders what was tested. Have you ever asked the stakeholders, oh, I've written out these detailed test cases, have you read them? They will not have read them. They say they will read them. They don't read them. So the stakeholders don't know exactly what was tested. It is also not needed for regulated industries. I have worked in medical, I have worked in finance, I have worked in telecommunications, and I've worked in insurance. 4 industries in Canada and the United States, all regulated. None of them require detailed test cases. There are many ways around having detailed test cases in a regulated industry that pass audits no problem. So yes, it allows for tracking, but it's actually not needed. It also doesn't show a methodical approach and thoroughness. It actually shows a lack of imagination and creativity, because instead of coming up with multiple scenarios, you come up with 1 or 2 or just a handful. So we'll get rid of that one too. It's also, as a big con, really boring. Is anybody here who does write test cases? Anybody? Okay. Who enjoys writing the test cases? Huh, interesting. Who enjoys executing detailed test cases that you have to follow step by step instead of, thinking and being creative? Nobody. Excellent. So, there is one more pro. It allows contracting companies to more easily sell their services. You'll see a trend. All right, another bad historical trend was testers provide a lot of information historically, usually big test reports, but they don't provide any useful or actionable information. So the test reports rely on metrics, typically that are generated by test case management tools. They produce beautifully pretty charts with burn downs and pass-fail rates and a whole bunch of other metrics that are useless. So useless that they're dangerous, because stakeholders are making decisions based on numbers that literally don't mean anything. I'll explain that if we have time later on. Someone asked that question. So, I just said this. They don't provide useful information in determining the state of the system under test, and yet stakeholders use them. We historically don't tell a good story when we're giving a test report. Historically, testers say, here's the pass-fail rate. We've executed 1,212 tests, and we have a 98% pass rate. Okay, can I ship? 98's a big number. 1,000 is a big number. Let's ship. They also don't link any bugs they found back to the business. So I found 10 bugs. Okay, are they important? Is it going to impact our customers? Is it going to impact us? Is it going to hurt anybody's chance of making money? We need to link back the defects to the business. But it's much easier to provide the bad, easy, auto-generate, hit the button and it prints out a chart and a map, and then you say, here you go, here's my test report. It's much easier, which is why it's so prevalent, but it is much less useful than doing a good test report. And this is not a talk on how to do a good test report. And very importantly, stakeholders do not care about the testing you've done unless you tell them why it's important that you did that testing. So if I say I've done 1,000 test cases, it sounds like a big number, but I might also say, but in that 1,000 test cases, we didn't test our payment system at all. There was no test for payment systems. That's much more useful information than saying I just executed 1,000 test cases. Another historic bad trend, and I don't know what happened to the title on these slides, but another historical bad trend is outsourcing most or all of the testing. So this happened very much in the late 90s and early 2000s. Big companies, Microsoft, HP, got rid of all of their testers in-house locally, and they outsourced it all, typically to lower cost areas. And instead of just supplementing their own internal teams, they outsourced the vast majority of it, keeping almost nobody internally. So the issues with this, if you are dealing with an outsourcing company, the good testers typically get moved off of your projects unless you're their biggest customer and move to other customers. When again, I was working at a fairly small telecom company called Newbridge, and Nortel was our competitor, I had multiple testers that finished their contract and went and worked for Nortel, a direct competitor of ours. Same outsourcing company, but the outsourcing company said, oh, you're good, you're doing really well, let's put you on Nortel's. And so all of the training I was doing to the people that I was working with was all helping Nortel. The contracting companies don't care about your business as much as they care about their own. They care about your business, but they care about their own more, so they're going to do what's important to themselves before they do what's important to you. Unless you're their biggest customer, you're going to get the short end of the stick. And this is the biggest point, your company has no intellectual property. So instead of having a team that's dedicated to your product and that sticks around for multiple years inside your company, and I don't care if you're overseas, like we ended up, when I was with Alcatel, excuse me, we had an Indian office, but we insourced in India. So we had an overseas office, but we hired the people to work directly for us instead of, so we could keep intellectual property, and that enabled us to train and bring new people up to speeds. And the new testers, they need to learn your products before they can really be effective, and the turnover rate is often much higher with contractors. So those were just 3 bad trends. Okay, not doing badly. What happened with those trends? Well, unfortunately, many of them are still around in some respect today. Although some of the trends fizzled off a little bit, like Microsoft and HP both had outsourced a lot of their testing, and by the end of the 2000s had actually brought a lot of that testing back internally because they realized that they had lost their intellectual property, and so they tried to get it back. Some trends fizzled out, like bad test reporting isn't quite as prevalent. It's not for a good reason, though. It's been replaced with even worse test reporting. The red and the green, everything you need to know. The pipeline, is it red? Is it green? It is not everything you need to know. It is taking good test reporting and simplifying it even more to the point of, once again, it's not necessarily helpful. I'm not saying that just because it's red and green doesn't mean it can't be beneficial, but it's not a test report. It's a point of a test report. Why doesn't that's, okay, you saw it was blank, and I just went ahead and came back, and it's not blank anymore. Weird. All right, so what are some current trends? And there's no title. I have titles on my slides. I know I have titles on my, actually, hold on a second. A disclaimer, see, I knew there was a title on it. So, my disclaimer is, I like automation. I really do. It's gonna sound like I don't, but I like automation. Automation is important to having a fast-moving pipeline. It's important to quickly give feedback to the developers if they've broken something critical. It's important to have a really good test automation framework that will give you a good sanity test, primarily in unit tests, but also some GUI and API level tests too. Good automation allows you to move faster. All right, now with that disclaimer, just remember that. I'm gonna talk some shit about automation. So, automate everything. Remember, I like automation. I hate automate everything. It is a horrible, horrible trend. So what are the pros? It allows for faster software deployments. Yes, that one's even gonna stay there. I'm not gonna take that one away. It can execute very quickly. Okay, good? If it's good automation, which most automation isn't, but if it is good automation, it can provide a good sanity check of your product, and it can reduce the need for some exploratory testers. Yes, I, who teach exploratory testing, will agree that if you have really good automation, you can have fewer testers. What are the cons? Well, It will only check what it's told to check. So if you code it to check that you go to a certain web page and that this number is 5 and it checks and it's 5, great. It might have another number beside it that it doesn't look at that might be wrong, but it will only check what you ask it to check. It's always going to check the same things and execute in the same way. There's no variation. If a human, even if they're executing the same written test, they will vary it just because they'll vary the timing, they'll get distracted, they'll hopefully do some interesting testing as well. Automation doesn't reason, doesn't think critically, it just does exactly what it's told. There's no creativity, no imagination. It doesn't ever see something interesting and go and explore it. It just, nope, I'm done. The maintenance costs can be high, and a human is still needed to investigate the failures, which can often take longer than just a human doing it in the first place. And we're not done. It can likely not reduce your costs because writing, debugging, and maintenance are going to take a lot of time. It will likely not allow you to eliminate testers, with the one exception of what I said, but somebody still actually needs to use the product, someone still actually needs to investigate the failures, someone actually still needs to find the bugs. It will likely not save you time, except in execution, because writing, maintenance, they all take time. And it will result in large gaps in your test coverage because, again, it only does the things that you have it do over and over and over again. And remember my disclaimer, I do like automation despite having 2 pages of cons. And it allows automation tool vendors to more easily sell their tools. Another bad trend, AI and machine learning can replace testers. I'll tell the story in a second. Let's go through the pros of AI and machine learning. Hold on, I'm getting one. You can say you work in AI and machine learning, that's cool. People will go, woo, that's neat. And it can be very useful for comparison automation. So visual comparison, number comparison, huge amounts of data comparison, very good at that. Okay, whew, we got one. All right. Cons. All of those cons that we went through on the previous first 2 pages, it's like you're a tier. You know, when you get, oh, you're a blue member, you're now a silver member. You get all the blue benefits plus the new silver. So we get all of the automation cons plus you don't even know what's being tested. At least before you wrote the automation, it wasn't testing a lot, but it was testing what you told it to. Now, I don't know what it's testing. Now I'm going to tell you the story. There was a company who is not a sponsor, so I'm going to call them out, called Test Rigger. I was looking for something instead of browser, so we had Browser Stack, Lambda Test, Test Rigger, and 2 others that I was looking at, so that we're going to be developing at Saxoff 5th a new app next year, a native app, and we didn't want to have to buy hundreds of physical devices and distribute them because we're mostly working remotely. So we got something like Browser Stack or Lambda Test, and so I was tasked as the automation test architect to compare these tools. So I looked at Test Rigger, and two things happened. One of them Daryl mentioned, if you were in his talk, that when I brought up the visual emulator of the physical device and I swiped up on it 3 times, it took 7 seconds for the first swipe, 5 seconds for the second swipe, 7 seconds for the third swipe to start, and then the phone crashed. I recreated it easily on an iPhone 12 and an iPhone XR. Just so, okay, well, that's no good. But then Test Rigger said, hey, we'll write you some automation. I thought, that sounds scary and bad, but I'm going to take you up on it. So I said, okay, and it said, how many tests do you want? I said, 10. And it said, that'll take us about 15 minutes. I said, perfect. Here's my URL. So with no other information, Test Rigger went to my URL of Saxoff 5th And 15 minutes later, it said, here's your 10 tests. So I looked at them, and none of them did anything even slightly close to useful. Every single one tried to log in with bad credentials, because I didn't give it any credentials. Every single one did a search. So the first 5 to 10 steps were the same on all 10 tests. Try to log in with wrong credentials, and then search for the word test rigger at Saxoff 5th. You know, maybe Gucci handbag would have gotten them something, but no. Anyway, nothing at all helpful. And so I thought, I'll modify one, because it says I can modify it. So I tried to modify it, and I like to think I'm a pretty smart guy who knows how to code, and I couldn't make it do anything that I wanted. So anyway, I had no idea what was being tested, and if you use some tools, they, low-code, no-code tools, they will create tests for you, but again, you really lose control over what they're doing. And how do they do it? Because it's artificial intelligence, machine learning. It learns algorithms, things that people have told it are important, from other systems. And then it tries to apply them to your system. But your systems are different. And if they're not different, then you're plagiarizing other people's systems, and you should stop it. But because your systems are different, it's using algorithms and rules from other systems that it's learning, and it's not learning. They're actually just pattern matching. Artificial intelligence has no intelligence. It's just pattern matching. And it might do some good pattern matching and do some good tests for you, but it might not. It might focus on the wrong thing. As I found out at Test Rigger, artificially intelligence code can be very difficult to modify. And if your interface changes, and I asked this of one of the premier AI companies, I said, we're looking at redoing our front end to a completely different look. And he said, oh, you'd have to throw everything away and start over. Fantastic. Excellent. Good to know. Oh, more cons. There's no reasoning. It's going to have defect. It's complicated software. It's really complicated software, so it's going to have defects. How do you know what they are? How does the company know what they are? And tools can be expensive and lock you in with proprietary code, and it's bad already that most companies, if you go to almost anybody at a company and say, what does your automation actually test? They can't tell you right now. They'll be able to even tell you less if they're using AI and machine learning. Oh, and guess what? It allows automation tool vendors to more easily sell their services. That's what these trends are. Almost all the trends are coming from vendors of something. ISTQB selling certification, contracting companies selling outsourcing, tool vendors selling tools that help you do it. And all of them seem to want to help the testing community, and almost all of them are hurting the testing community by the way that they're marketing their tools. Some tools can be very useful. I was talking with Daryl, who works at Mabel, about how Mabel might be able to help us, and he had some really good ideas as to how the Mabel tool could help us. But if you look at their marketing, especially from 2 years ago, actually even 1 year ago, it's very detrimental because it indicates that you're going to replace human testers with the automation. Wow, I got to go way faster. All right, eliminating the role of human testers. No pros at all. I'm not even going to pretend. Cons, no one's actually going to use the product before it gets deployed. There's no one to question, ask the hard questions beforehand. No one can think critically and dig deep to find important bugs. Your customers are going to do a whole bunch of really interesting and cool things that your automation won't do, and you need a human there to look into it. And if there's no customer advocate saying, that was a really bad experience, we need to change that, and it's just it does what we wanted, it's going to help. So you might say saving money is a pro, but with no one overseeing the automation, your product's probably going to suck and you're going to lose money in the long run, is essentially what that says. So, holy crap, I got to go quick. So I expect the next few years are going to be difficult. It is going to take time for companies to, they're actually going to have to feel the pain of these trends. These trends are so far out of the station that they're being ingrained. I'm sure all of you have heard, oh yeah, we're going to automate that, we're going to have fewer testers. They're just trends that I think are going to reverse, but it's going to take a while. Hopefully they'll realize that the automation is going to be helping them supplement testing, and it's not going to be replacing it. So I propose that companies need to invest in good automation, which can reduce the number of software testers, but not eliminate them. All right, so we need to make ourselves more valuable, providing actionable information to stakeholders on the status of the product, finding defects that automation is missing. It's really not that hard, just use your product. They're all over the place. I've often run a quick test saying, here's a released piece of software, let's test it. There was one, a running app made by a underwear company that has Good Armor, I guess? Anyway, they're a running app, and out of the 6 teams that we had testing it, 5 of them said it shouldn't be released. It was already released, that's how bad it was. Anyway, you want to track the value that you're bringing and share it. If you make yourself important, they're not going to get rid of you. You need to make themselves valuable. Stop wasting time testing stupid, simple stories. If you have a 1-point story or, hey, a checkbox needs to show up, can you sign that off, please, tester? No. Is the checkbox there? Did you see it? Then just sign it off. I don't need to waste my time doing it. But if I test at the epic level instead, or at the feature level, I can use my creativity, my critical thinking, and I can find bugs that automation is going to miss. So giving the developers the responsibility for the easy stories and step back and focus their attention as a tester at the epic level, I think that'll be really important. And also, in your test reports and in your reporting, be a customer advocate. Say how the bugs are going to impact the customer and your own business, and explain why some defects are more important because automation can't. All right, last slide. Whew. Everyone needs to speak out about the importance and value that testers provide. We provide creativity, critical thinking, we question things, we can provide good test reports. Ask me later. Actually using the product. What is a manual tester? Well, one, it's like a manual coder, it's just a tester, but it's someone who uses the product like a customer. Being an advocate for the customer, finding defects that automation can't find, thinking differently, and the more voices we have, being an advocate of higher quality. You all need to have 3 eggs and say, testing is important. That works better if you translate that into Spanish. Anyway, thank you. This says thank you. It really does.
So much, Paul.
Overtime. Oh, it's 3 minutes over.
Okay, so we're getting near the end. We have a few minutes for questions. So anyone want to go first? Want to volunteer? Break the ice?
Because I yell.
Then.
Oh, Eric's not scared. Oh, no.
There we go.
Why do you think it's so hard to communicate a value of testing? Why are we continually playing from behind and fighting uphill?
Honestly, I think it's because of that goes back to my very first slide. We, as a profession, have been sold the short end of the stick, being told how to do the job. People think that, oh, if you just write out the test case and you execute it and you enter your data in ALM, that's all you do. What so many people don't realize is that testing is hard. It's a thought-provoking, challenging, creative process, but it's been commoditized by so many vendors, so many companies, right from the beginning of the ISTQB saying, this is how you do testing, it's easy. I'm guessing most of you have seen the ISTQB syllabus. It's so in-depth and so, no, it's horrible. By the people who don't understand testing, well, our former boss, who doesn't know testing in one of my first meetings with us. I've never seen him talk at a software testing conference. I've never heard of him before. And in my first meeting with him, he said, I know testing. I thought, no, you don't. Not based on what we just talked about. You were talking about detailed test cases and really, anyway. I honestly think it comes down to the commoditization of software testing has what, from way before you and I started in this field in the 90s, it started out that testing is something that can be simplified to the point that it's easy to outsource and easy to do in a rote way, even though it isn't. And that has gotten ingrained in the industry, sadly.
Okay.
Way at the back.
We
you can
have
get
another
exercise.
question in the back. There we go.
Okay, so I agree with everything that you said regarding the test cases. So what do you suggest we should start using instead of boring, detailed test cases?
Oh, that's a good point. So instead of detailed test cases, I'm guessing everybody who executes your detailed test cases knows how to use your product. Do they need to be told that when I put in valid credentials that my expected result is to be shown my account screen? You know, I'm going to get logged in? You don't need to say that. So if you do need to have a scenario or a workflow, just do it at a very high level. Just say, log in, select a product to purchase it with Apple Pay, make sure you get the email at the end, because we're checking email. That's it. You don't have to tell people the exact steps to do, or you could just say, you don't even have to say log in. You can just say, buy products with Apple Pay, don't forget to check the email. I keep saying the email because that's something that's currently not working on the thing I'm testing. But so if there's something really important, you can say, don't forget to check that or check this. But honestly, just describe the scenario as loosely as you can, hitting the highlights, the important things. So if they need to pay with Apple Pay and credit cards and PayPal, then you can say, make a purchase using all the payment methods. So that, I have to run this 3 times using the 3 payment methods. But I don't have to write a detailed script out that says, put in 54545454, my favorite MasterCard fake number. It's all 5 4s. You don't have to specify that. It doesn't add any value. It just takes you time. And the way I do it, with it's just a high-level scenario, the maintenance cost is 0, because it never changes buying a product using all the payment methods. That's the same. But if I say, click on this checkout, but now the checkout button's moved, I have to go and maintain all the scripts that tell me where to click on checking out. So I'm just adding costs and slowing us down when really I just need to have something very, very high level as a scenario or description.
Okay, there we go.
Well, I will do the obvious question. How can we create better reports?
That is a one-day tutorial that I do. So the big thing is you want to tell a story about what was tested, what you tested, why it was important that you tested what you didn't test. So I tend not to put any metrics. I don't say a percentage or I found 8 bugs. I don't put that in my test reports. I list the bugs. If I found 8 bugs, I'll list 8 bugs. If I found 100, I'll probably just pick the top 8 or 10 and say, there's many more at this link. But really, I talk about test coverage. I usually use a mind map, color-coded mind map, to show what was tested deeply, what was tested shallowly. So I make a mind map of the product and I show the coverage. I have a quick executive summary at the beginning that just says, we completed our testing. We found some show-stopping bugs. They appear that they should be fixed in the next week. In general, the product looks better than the previous release, that type of very high-level stuff. And then I show test coverage. I talk about the bugs that we found. I talk about risks that were addressed and were not addressed, any open questions, and I'm sure I'm missing a couple of things, but that's pretty much, and I usually just use a PowerPoint slide that has headings. I just use a PowerPoint slide, and it's like 5 to 7 slides, and that's it.
Great. There was another question in the front. No?
No, she
Okay.
doesn't want to talk anymore.
I know.
It's fine. I understand.
¿Alguien más? Nobody asked you the question you wanted to be asked about
About the metrics?
yeah, dangerousness of the metrics and stuff.
Yeah, that's fine. Okay. Yeah, no, we're out of time.
Okay.
Hold on, wait, sorry. She's going to ask about the metrics.
Let's go.
No, it's not about the metrics. I'm going back to the test cases. I agree with you about using test scenarios instead of writing detailed test cases, but what indicates that you have a new test member on your team and that
Excellent question.
that person.
So if you don't know the product, just like the lady from Nortel who had the experienced people on her team, if you don't know the product, you shouldn't be executing detailed detailed test cases or scenarios. You need to pair test with somebody. So when I, again, worked in telecom, for the first month that somebody joined my team, they only pair tested. They weren't even allowed in the lab unless they were with somebody else. And then for the next 2 months, they weren't allowed to raise defects without going over what they did with the team, because I tested a very complicated, tiny piece. But it's pair testing. You need to bring the skill level of the people doing the testing up so that they know what's a bug and what isn't a bug. And they also need to have a good rapport with other testers, so if they see something that wasn't covered, they need to say, oh, hey, Sabrina, can you tell me if this is a bug or not? So, make sense? Because just giving them the detailed test case, they'll go through like a robot and they won't notice any of the other bugs, and honestly, they're going to miss most of what they should be finding.
Okay. Thank you so much, Paul. Okay, so now switching back to Spanish.
Gracias, Paul.
Thank you, Paul. Thank you, everyone that was here, everyone who collaborated. So this was possible because of each one of you that came here and the people here as well, just cooperating. So I think this is good for the experience we lived today. So thank you so much, everyone. Thanks to the sponsors that helped us pay for this. We dreamed big from the beginning, and we wanted to prepare this in the best way possible. Something we were talking about with several of you in the hallways. Isn't it good to come back to face and the feeling of community gathering in one place and just meeting faces? I had the chance of meeting some of you again, and that makes me very happy. I felt like today was a party. Well, the whole week, but we started with a Whopper, and so this has been great. I'm very grateful. I would like to thank you for being great hosts. And I think we managed to achieve everything in the time frame we had, which was a challenge because we had a lot of content. Thank you, guys. I want to close with something that I was saying at the end of the Whopper. It's kind of sad saying, hey, this is finishing, but this is only the beginning. The first Whopper ended, and it was the beginning of this, of what happened this week. Think about everything that is a beginning today. In a few years, we're going to think about how many doors and opportunities we are going to find from this conference. I hope that happens a lot. And let's meet in the next Quality Sense conference, be it in Chile, the United States, or here in Uruguay. We're dreaming big. And why not? I'll share this dream. How would the world be if we could have conferences in the United States speaking in Spanish? How would that look like? What has happened traditionally, what we assume, is that if someone comes from the US or from Europe or from another country, they talk in English, and we have to handle that translation or understanding the other language. And if we go over there, we have to talk in English. And it's a high barrier. I had a lot of trouble with my first conversation in English. I had a really bad time. So it's a high barrier. And if we manage to break that by organizing a conference that makes it easier for us, then maybe us as Latin Americans, we can be more exposed to the world. Our talent can be more exposed to the world, and we can grow a lot. So thank you a lot. Thank you so much.